Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing out the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
All right, what's up, everybody? Ooh, yeah. Wow, what a weekend, I tell you. He's back. I told you I'd be back. I am... I don't know how long I'm going to stream today because I'm pretty sure I'm sick. Yeah. Like, I'm all congested. My body aches. Everything hurts. I know. I had kind of like a legendary day yesterday. The night before, I was up till like 4 in the morning because I had to drive my friend to the airport at 3. And then I woke up at 10. I ran a 5K. And then I went to this event to go help pack up and clean up and like move things. And that went till like midnight, 1 o'clock, 2 o'clock. And then one of the people there who runs one of the stages, his car, like, just stopped working. The starter broke. So, I had to bring my truck, load all his stuff, take all his stuff to downtown LA. Yeah. So I didn't get home till like 3:30. And I just, like, slept. Like, a hard, like, 10 hours. I don't know. I feel really tired. I'm exhausted. Which I think is, yeah, everything hurts is it's a classic sign of aging. It really is, honestly, Laz. What's up, dude? Yeah, I didn't even, like, really party last night. I was just exhausted. I was just tired. What's up, Becky? Becky, you want to submit your question? I know I didn't get to help you yesterday because we ran out of time, but please do. I'm going to muscle through it for you guys. So we're going to do it. Plus, I think if I, like, distract my brain with math and science, it'll stop focusing on being sick. Yeah, nice. Let's see. You know, I always have ChatGPT kind of figure out for the live announcements what, like, national day it is today. And apparently today is National Coaches Day.
My man!
Which I thought was fun. Because I kind of think of myself as a coach, I guess. Like an academic coach, maybe. Like a mental coach. Yeah, throw me some warm-up physics, please. Please throw me some warm-up physics. I would love some warm-up physics. Let's warm it up. Let's warm it up with some warm-up physics. So I can feel better about myself. One moment, please. Nice. And we're the Bad News Bears. Yeah. Bro, the Bad News Bears was those group theory set questions. I was just, I'm sorry. Equity, if you're watching, I'm sorry. You've now surpassed me. I remember helping you out years ago when you were learning pre-calculus and now calculus and then maybe some vector cal, but now you're in like discrete mathematics. No, I'm sorry. That ship has sailed. I've gotten you as far as I can. But that being said, yeah, physics I can help with, like, to a lot higher level. Math is kind of a necessary tool for physics. Algebraic topology. No, exactly. That's what I'm talking about. and I'm down to like learn stuff for sure. But at some point I just check out, especially if I don't know, we're during a busy part of the stream and I got a lot of other questions coming in that I know I can answer, but I'm getting hung up on something I'm trying to learn. I'm just like, I'm going to punt on it for a second. That being said, like, no, if you need help in more advanced math topics, Zach has ramped up his tutoring schedule, which I think is awesome. Or his streaming schedule. I don't think he calls it tutoring technically, but Zach does a lot of great help. He's doing this new like math chat on a topic. Here, I copy and pasted his Well, thanks, Sam. Appreciate the subscription. That's really dope. Nice. Yeah. So sweet. Yeah, we're gonna go through it. Zach has some cool new announcements which kind of parallel what's happening. I do need to drink some water, thank you. Kind of parallels what's happening in our server as well. Thank you, Indians fan. New badge. Wait. Oh, do I need a 45 badge for you now? Please tell me. I love this, Sam. Sam, dude, you've been subscribed for more than 3 years now? 3.5 years almost? Holy shit. What's the new badge I need? Oh, no, you have a 42 badge now. Nice. Okay. Okay, I think the next one's 48. You just hit it. That's sick, dude. Sam is probably like, here, if we look at the closing credits. Yeah, Sam is the most. Or next. Yeah, well, Sam, you're on there twice now, apparently. It says play Moats twice. I don't know, I gotta go. I think it's gotta update something. Penn Center's got 21. Yeah, I don't know why it's doubling on it. Whatever. We'll figure it out. Okay, anyways. That's not the end of the stream, sorry. I was just showing the leaderboard. Yeah, no, I appreciate all the subs and stuff. But yeah, what I was talking about is Zach's opened up more tutoring. I've opened up more tutoring streams. And we're actually going to collab together on Thursday. There's going to be a fun thing on Thursday. I'll show you what it's going to be. Sorry, let's get rid of this. Yeah. So this is Zach's schedule. Kind of mirrors what we're doing. So Zach is doing a cool math topic. I think like every Tuesday is what he's doing. And so he's doing a discussion about division of fractions and mathematical mindsets. This is cool. Honestly, like, I can't tell you how many times I've had to teach dividing fractions in the last week. It's a very basic thing, but I think there is like a mindset that people kind of get messed up on. So I appreciate he's doing that. And then, yeah, Thursday, Zach is doing a pod. So I was on Tiny Toxic Tofu's podcast last Friday. I'm going to be on Zach's podcast this Thursday. The first ever E to the 2I podcast. I love that. It's such a cool name. Exactly. But yeah, we're going to discuss, I think what he's doing with this podcast series is he's showing how like math interacts with different fields. And we're going to talk about how math shows up a lot in physics. I mean, I say math was created for physics, honestly, sometimes. Yeah, that's going to be a little bit earlier. So for me, I guess that's 4:30 p.m. my time. I think, well, here we have it. It's on the calendar. So if you go to the calendar, it's going to be listed under here. Yeah, whatever this is. So 4:30 Pacific. I think that's 7:30 for East Coast people, 5:30 for the Mountain people, 6:30 for Central. So yeah, come on by that. That's going to be fun on Thursday. And then I guess he's doing a cool, like, he holds down Saturdays pretty well. I think I'm going to start taking the mantle on Sundays. You were cool to see me in Tofu stream. Yeah, that's cool. That's cool you follow Tofu. I know her through the TKF, the Knowledge Fellowship Discord, and yeah, she's a fellow physics like professor, lecturer, streamer person. So I hit her up like a year ago, asking her like, you know, hey, you want to collab on something? And then she hit me up and was like, hey, I'd love to get you on my podcast. And then she really liked that stream. She had a really fun time with it. And she said she'd love to be on my podcast. So I have a podcast series I run. I'm going to do more of it now this quarter, but I kind of stopped over the summer. But that's where we have the students really ask like really cool questions about guests of all sorts of different backgrounds and things. Okay. Right. So that's the announcement so far. I got a group podcast with Zach on Thursday. We have more office hours during the week. She works on batteries. Yeah, she's cool. She does a lot of like tech stuff. I guess it's Tiny Toxic Tofu Tech Talk. Yeah, she's cool. And maybe there will be more collaborations to come. I'm also kind of in the middle of some other potential job interviews since UCLA didn't have money this quarter for me to teach. So we'll see. Fingers crossed. I'll let you guys know what comes up and what I can and cannot talk about. Some of it I have to like sign NDAs for. But anyways, okay. That being said, it looks like we already got a good question from Becky. I already love this. I already love what Becky's already throwing some complex analysis at me already. And then a good question from Indians fans. Okay, so let's start off the stream. Welcome everyone to Actual Education Office Hours. My name is Dr. Gold. This is a stream that helps you out with math, homework, science, homework.
My man.
All sorts of fun stuff. Yes, Jeff is so happy. We're doing math.
That's dope.
Jeff loves math. Jeff is a math man. I do need to clear the queue a little bit because we did just do Measons yesterday. Jebediah, if you show up on the stream, Jebediah, I will hop into yours next. But for now, I'm going to help out Becky. This is for you, Jeff. This is for you, Jeff. Give it up for Jeff, dude. Thank you, Becky. Yeah, okay, here we go. I might need help solving this one, actually. Because I have to remember, like, how to deal with complex numbers. Spoiler alert, they're complex. Okay. Let's see. And then let me start the TikTok. Hopefully that starts working. Sometimes I gotta, like, open the session. The Z form? Yeah, I could agree with that. I think that might work. Let me see if this works. Sorry for TikTok. TikTok's sometimes kind of weird with getting my chat to work. TikTok. Come on, TikTok. Be nice. We actually did really well on TikTok last week. I hit almost like 30 viewers, consecutive viewers, which is like insane. I think I have to like click on this maybe. Maybe it'll get it. There's my chat. I see my chat. Just come on, girl. Be nice. Whatever. It'll show up at some point. My homework has a problem just like this. Oh. Okay, maybe we'll help you out with it then. Okay. This is the first 2 parts of a question with more parts. If you're vibing with it, I can resubmit the rest. Okay, nice. Yeah, if we're vibing with this, and like Jeff gets mad that we're not doing more math because it's all physics, 100% we're gonna hit this stuff up. So it looks like we're dealing with complex numbers. We got to solve some stuff. I don't like stuff in the denominator. No, it's usually a bad thing. Maybe this relates actually to what Zach's gonna go over tomorrow with fractions. Also shout out to Don. Don's great. Nice. Don, you're in school, obviously. You're in grad school, so I know your streaming schedule is probably not as regular as it used to be because you got like homework and stuff. But let me know if you want me to like add you to this calendar. I know technically Penn Center owns it, but I think like me and Zach are the only one that uses it. Because I'm trying to like refer more people to times where other streamers are streaming. And to me, it's like the most up-to-date thing. Rather than me having to constantly go into Twitch and like switch my schedule. Like I can see it on Google Calendar and I just move it around. Just like, I can't teach today, I can't teach. I can't teach, I can't teach. I just put it on. Multiply both sides. I agree. So, well, also this to the third power, dude. This is kind of gross. What do you want to multiply both sides by? By this, you think? Solutions are denoted by Z0. You know what I see though? Isn't this already something cubed? This is already a cubic, no? Yeah, cool. Yeah, thanks, Don. Yeah, I'd love to like just to tell other people because I sometimes have to stop streaming. I'd love to say like, hey, this awesome guy Don is streaming like tomorrow, like in the afternoon. Go find him. And they'd probably find you. Okay. So let's see. I feel like this is already a cube though, right? So we can rewrite this as negative 2m by its conjugate. Yeah. All you need to do is show that the constant term is real. What's the constant term? Or, ooh. Bro, last time I did this kind of math in 2020, 2025, my brain is smoked from the Zaza. What's the Zaza? Excuse me. Hey, I'm autistic and was never good at math. Do you think anyone can learn it? Yeah, no, anyone can learn math. Just some people take more time than others. Sorry, this is a cubic polynomial. I see. Are you saying, for instance, if I were to move this over to this side, are you saying this? Like a difference of cubes, maybe? Yeah, math is like a puzzle. Yeah, that's all math is. Are you saying like this? This is a difference of cubes, no? Right? And does this have a special form I can then solve for? That works, right? Yeah, okay, let me figure out what difference of cubes is. I think it's like a minus b, then it's a squared plus ab plus b squared. Let's try to do it this way. It's just an idea. I don't know, it might be wrong. I'm sure there's some better math formal way to do this, but I'm just going based off of what I know from, you know, pre-calculus. It should work, right? Yeah, right? Okay. So yeah, anytime you have something cubed minus another thing cubed, right? We can write that as the two things differed from each other. So I can say this is the same thing as z minus 2m over 1 plus the square root of 3i. Math has many solutions, that's true. Minus 2m, so that's plus 2m. Okay. I know this has to equal 0, right? And then we have a squared. So that's going to be z minus 2m. I don't like this last part. I think this last part is ugly. Really not nice. Plus, so that's... Yeah. Well, it's actually going to be minus then, right? Or... Let's do it this way. What's up, Ruth? I'm going to flip this. So instead of z minus 2m, I'm going to do 2m minus z. As like a way of absorbing the minus sign, right? I can definitely do Calc 3, yeah. Yeah, if you want to submit one, send it to the... There's a website down there. actualdiscord.com/submit. And then this is squared. Okay, plus negative 2m squared. What type of math is this? I would say this is probably complex analysis, no? I'm sure AI can do this 10 times quicker. I mean, the same way like a forklift can lift weight a lot more than a human can, but you don't get stronger from using machines, so. You have to actually do it if you want to build up brain power. Calc is short for calculator. Arkan says, what's functions? Go check my TikTok. I literally have a video on functions. I believe they're microwaves. Okay, so let's look at this one. So I have to have this is equal to 0, right? I can do truth tables, yeah. Let's do. So we have z minus 2m over 1 plus the square root of 3i is equal to, so minus 2m is equal to 0. And sorry, what are we looking for? Express z, not z in terms of m. Oh, okay. Oh, okay. This isn't bad then, no, is it? This isn't college, bro? Oh, okay. I mean, this is TikTok, technically. Social media. So let's move this over. Let's multiply that by this. And then we technically got to add 2m, right? Yes, anybody's asking, can I do this? Can I do this question? Give me a screenshot and add it to the queue, and I will do it. Yo, what's up, Zach? I was just talking about your awesome schedule that you posted and how we're going to have this super fun collaboration on Thursday. And I really like that you're streaming more. I like this math topic you're doing about division of fractions. I think everybody could use these days. No one seems to know how to divide fractions. I definitely help with physics. Yeah, my PhD's in physics. Okay. What do I do with this though, guys? Do I just pull a 2m out? I can pull a 2m, right? This is 2m times 1 plus the square root of 3i. But then this one is going to be kind of a mess to deal with. Here's the problem. Yeah, let me show you guys. Plasma physics. That's my field of study. Show it. Show it, he says. Show the question. That's the question, guys. Yeah, I know it works technically, but that's only one of the solutions. This should have 3 roots, right? Because it's something cubed. So usually when something in the complex plane has 3 solutions, it's because you're going to have something with like e to the, I don't know, I pi over 3. And then something with like e to the 2 pi over 3. And then it's like e to the 4 pi over 3. Or maybe it's this? Is this how this works? How do the solutions work for this? I think you want 3 roots, right? Or, wait. I think it's the original one. Right, it's this. And then cube root each side. I think that's kind of what they want, because I think they want this. Yeah, 120-degree rotations, exactly. So this should be e to the I times the 2 pi over 3. And then this should be e to the I 4 pi over 3. And then this is e to the 2i pi. This is Pete God's work, yeah. 1 plus I square root of 3 cubed simplifies a lot. Okay, well, let's... Okay, so, you know, sometimes we go down a road, and it's not the road we want. Because I'm seeing this is getting a little bit too complicated, so let's do it the other way. Good job, Jaro. Appreciate the slang. Okay. So, we've already analyzed it. This is the same thing as negative 2m, all cubed. So, if we take the cubed root of each side, right? Here, let's just, like, call this thing, I don't know, let's call this, like, x. Let's call this, like, x, right? So, now I have x cubed is equal to negative 2m cubed, right? And then if I take the third root of both sides, right? We should get that x is equal to negative 2m. And then there should be 3 roots, which would be e to the pi I. And then this is going to occur at, right, at 0. 2 pi over 3. And then 4 pi over 3. Right, yeah, we did do that. I tried this. I tried the difference of cubes. It didn't really look too nice. E to the 6 pi over 3 troll account. Yeah, that's what we need. These are 10th graders? This is not a 10th grade question. There's no way this is a 10th grade question, Becky. I love you, but no. This is a college level question. Yeah, the third roots of unity. I agree. Okay. Okay. So then, let's see. This whole thing. Let's do like the first one. Let's just do the first one, which would be. I gotta think how this works. E to the 2 pi over 3. Oh, but we can put, okay, look what this is, chat, watch. I'll do up to like diff q, really. Okay, this right here, right, this solution is the same as, if we were to put this in like real and complex form, right? E to the 2 pi over 3, this is the same thing as this being 60 degrees, right? And if this is 60 degrees, then this side will be square root of 3 over 2 in the complex plane. And then this will be negative 1/2, right? So let's just look at the first one. I don't really care about the zero solution. That's like whatever. Let's look at the first one, right? Which is when we're looking at 2 pi over 3. Okay, so in that case, x is equal to negative 2m. And then that's going to be negative 1/2, because that's a real part, plus the square root of 3 over 2i. Nice. Okay. And then x we know, right? That was equal to this whole thing here. So what? We had z minus 2m over 1 plus the square root of 3i is equal to this. Negative 2m. Oh, brother. This is so cool, actually. This works out really nice, Becky. Because, look, you can pull a 2 out of this, right? Pull the 2 out. Now this cancels. Right? So you're just left with negative. And then this was plus, right? Then I can distribute the negative back in. This becomes plus. This becomes minus. Right? I think so, yeah, no? And then when I cross multiply this is literally a difference of squares. Oh, wow. So now z minus 2m is equal to 1 squared minus the square root of 3i squared. Yeah? So I get z is equal to 2m plus 1 minus plus 3. Right? Because square root of 3i squared is 3, but the I squared is a negative, and then so you get a plus. So it's just 2m plus 4? Or am I missing something here? Bro says omega squared, and 1. Well, I think it's 1 omega and omega squared, right? So this right here, that's 1. This right here is omega. And then this right here, sure, is omega squared. You have to do for the other 2. I feel like I'm close here, dude. Right now? If you want to do it separately, then do that. Okay. I could use Vieta as well? Oh, okay. Yeah, okay. Because wait, here was the first solution we had. We had that x was just equal to negative 2m, right? And then that's this solution, e to the pi I just 0, right? That's just the 1, right? So that's z minus 2m. I'm like close. I know I'm close. Well, that's the next part. I think they still want z0, z1, and z2 in terms of m. Right? The Mathematic Fanatic. That's a cool username, by the way, bro. I like that. Okay. Square root of 3i, right, is equal to negative 2m. So we multiply that through, right? Z is equal to 2m. And then it's minus 2m. 1 plus the square root of 3i, right? What's up? Thanks, dude. Oh, okay. Oh, 10th graders. Okay, I can see this as like a 10th grader problem, maybe. Yeah. Yeah, right? Okay. Oh, and then, wait. This part, let's just leave this. Let's leave this in here. Right? This was the either e to the 0, or let's call that a different thing. Let me call that, maybe, do I want to call it y? Let's call this y. Yeah, here. Where y can equal either 1, that's the first root, right? E to the 0. And then it can equal this one, which is negative 1/2 plus the square root of 3 over 2i. Or it can be negative 1/2 minus the square root of 3 over 2i. Right? We agree with that? K1 plus... Oh, they all add up to it? Oh, okay.
Nice.
Is that right? It's the summation of all of them? I guess so. See, this is where, like, my knowledge on, like, complex stuff starts to... Oh, okay. Yes, okay. 1 plus omega squared is equal to 0. Okay. Okay. No, I got you, Radiant. I got you. So you're saying x is equal to negative 2m, and then it's e to the 0, right? I don't see where you're adding them together either. I think what's happening is... This is the little part of complex analysis I don't exactly understand. And you're saying this, and then this... So e to the 0, so this would be 1. And then plus... I see... That, and then if you... But wait, if you add that and that doesn't cancel. You get 0, no? I don't think you want it to all equal 0, though, no? Did you try factoring out? Yeah, we did. For here? Yeah. Yeah, I don't think you want them all to add up to 0. I think we're finding 3 solutions. So in the same way that, I mean, let me show the basic version, right? If you say like x to the 3rd, is equal to like negative 1, right? Isn't that, sorry, x to the 3rd is equal to 1. let me get an example of this. Yeah, so say you have this. X to the third is equal to 1, right? You can move this over and say this is x to the third minus 1 is equal to 0, and then you can factor that as a difference of cubes to solve. But I think the fancier way to do this, right, is to identify that you have a solution at e to the 0, right, which is just 1. So x is equal to 1. And then the other solution this works so the sum of the roots is 0. Yeah. And then you have x is equal to e to the I, and then it's 2 pi over 3. And then it's x is equal to e to the I 4 pi over 3. And I think this comes out to be, what, this is negative 1/2 plus square root of 3 over 2i. And then this is negative 1/2 minus square root of 3 over 2i. Yeah. My hand pains. Do you want to join my Discord and just talk? You can come on the stage here if you want to come talk with me in the chat. Here, let's let chat like kind of figure it out. I like this. We have chat in YouTube and chat in TikTok, and they're disagreeing with each other how to do this. There is a Discord link for all y'all that are watching. Like, so if you go to actual discord.com/submit, there's a link here to join our Discord. And if you come on to the stage channel called Office Hours Stage, I'll invite you up and you can get live on the stream here and duke it out. I think this is the same thing. I like to look at parallels, right? If I have just x to the third is equal to 1, right? If I have just x to the third is equal to 1, I figure out like the base solution e to the 0, and then I figure out how many rotations it would take to also get back there. And with e to the third, you get, 3 times around. So that's going to be 2 pi over 3, 4 pi over 3, and eventually you get to 6 pi over 3, which is just 2 pi. Yes, if you have a question with any other stuff, please feel free to submit a screenshot of it. Yeah. Right? And so that's what I see here. This is a similar situation of you have x to the third is equal to negative 8 m to the third. Do I have a callus? I don't really have a callus. River, is this you? Let me know, River, if this is you. Dude Waldo. I got a couple people in my chat now. You're on YouTube. Okay, cool. Here. You want to come speak? Just be nice. Don't get me banned on Twitch.
All right.
All right. What's up? What's up, River?
Hello. So what are we doing here?
So what are we doing here? Yeah. Yes. You know what to do? Here, Dude Waldo's gonna come up and say something. Here, Dude Waldo, come up. Show me. Talk with words. I know speaking like sucks.
Okay, hello, can you hear me?
I can hear you. What's up, Waldo? Welcome to the stream.
Okay, thank you. So we were able to solve for x. Wait, okay, so you set that equal to x, and then and then what did you get for x?
Sure. So
I mean, what did you get for z, rather? Sorry.
For z, I got down to where was it? Let me erase all this. Sorry. Wait, this is wrong. This is what we got. Okay. So I said x was equal to negative 2m, right? Because it was x to the third was equal to negative 8m cubed. Yeah.
Yeah.
And then I said x was this thing, right?
Right.
And then what I'm going to do is negative 2m. I know this, I think, has to split into 3 different, like, branches so
Correct.
far, right?
Yeah, so putting a y on it is a great way to represent that.
Awesome, cool. I think that's correct, right? So then I have this
really right.
negative 2my, and then I'm just going to multiply this on through the other way, right?
Yes.
Right? So let me think how this works, sorry. Yeah, wait, x is equal to negative 2m. So then I'm going to do negative 2my, and then this is all multiplied by 1 plus the square root of 3I, and then this is all, then I'm going to add the 2m over, right?
Yes.
Okay, cool. All right, good so far. I'm going to erase this real quick. Okay. And now I think I want to pull out a 2m. So I'm going to say...
Yeah, that is a good idea.
I think so, right? Yeah, okay. And then this is... what's this going to be? Negative y times 1 plus the square root of 3I plus 1, I guess.
Yes.
Okay.
Hmm.
And now, do we just substitute in what we know y is, right? So y could be e to the 0, which would be 1, right?
Yeah, it could be either 0 or it could be, the other two.
Right, it could be e to the... Yeah?
And the actual question is calculate the product of all three z.
Correct. Eventually, yes. I want to get the first 3 roots of z first. So if I plug in the... Yeah? I mean, that's what the question asks for.
I have a suspicion that calculating the product might actually be easier than calculating them individually.
Sure.
I could be wrong about that. Oh, never mind. It literally asked you to express it.
He literally asked us
so-
to do it. So we kind of have to, unfortunately. Okay.
Okay,
So-
well then you've just about got it.
I think so. I mean, let's see. So let's see if y is equal to 0, because Femvox also in the chat, he's a pretty good math guy. He says he gets z0 is equal to negative 2m. I think I'm going to agree with this. Right.
Y
So
doesn't equal 0. Y equals 1.
sorry, y equals 1. Yeah, it's e to the 0. Okay, so y is equal to
Right.
1. So I get z is equal to 2m, and then that's going to be negative 1 minus the square root of 3I plus 1. Right?
Yeah.
Okay, so this will cancel, and I just get z is equal to negative 2 square root of 3m, I think. Oh, with an I on it,
Yeah.
right?
With an
Okay,
I,
so
yeah.
I think that's one of the solutions. And then the other one we said was when you're at e to the 2 pi over 3. So that's this, which I hope is like a... So here, we're gonna box this. This is like 1 root, please. Okay. All right, then I have that, but that's for this case. Radiant is happy in the chat. I'm glad you're happy, Radiant.
Good job.
Thank you for the patience, everybody. Yeah, I struggle with imaginary numbers. Trust me, it's because they're imaginary. Okay, so this negative here on top of this is that's gonna make it 1 minus the square root of 3 over 2, right? So that's 1/2 minus the square root of 3 over 2i for what used to be up here. So this is now this.
Yeah.
Good. And the reason I like that is because I can, first of all, I can pull a 2 out of this,
Yeah.
right? Or I can pull a 1/2 out. So I'm going to pull a 1/2 out of this. This is now a difference of squares, which I love. Yeah, imaginary numbers are like vectors. I agree. Yeah, it's hard to teach students that. They don't get because they don't even know what vectors are. I didn't know what vectors were in like 8th grade. So then this is 1 plus 3 because it's minus square root of 3 squared, but then it's also minus I squared, so that's a plus.
Right.
Plus 1. Okay, that's 4. Half of 4 is 2. 2 plus 1 is 3. So then we get 6m. I think that's the other run. Vectors equal arrows. I agree, Zach. Okay.
Man, I was about to cancel that 2 and the 1/2, but you're
No, you
quite
can't do
right.
that.
Yeah.
Yeah,
Okay.
You know, I think I fucked that up earlier because I think I did. I just canceled this, but you still have this.
Right.
Yeah. Yeah. Okay, final one. Let me get the original thing
I
again.
see the original equation.
Can you see the original? You want to see the original equation real quick?
Yeah, I just want to write it down, see if I can do it.
Cool. Yeah, this is it. Here, I'll post it in the chat. One second. Let me copy this.
Yeah, done.
There you go. It's in the stage chat if you want to check it. There you go.
All right, thank you.
Okay. Okay. So then our final one. God help us. Z is equal to 2m. Then it was all this, but I'm going to replace the y with something else. Okay, so we're gonna move. Thank you. Copy paste. Right. The other one was this -1/2 minus the square root of 3 over 2i. Okay. Okay. Interesting. So that minus is going to cancel this and this. So then that's square. This is going to be weird and complex. No pun intended there. Oopsies. Okay, this is going to be 1/2, and then this is going to be 1 plus the square root of 3i squared plus 1. Okay, so don't cancel the 2 halves. The 2 halves. Don't cancel the 1/2 yet. So 1/2, 1 plus 1, sorry, minus 1 squared minus 3 plus 2 square root of 3i, all plus 1. Okay. Algebra is tedious. -2 plus 2 square root of 3i. Okay, but now the 1/2 can come back in. That cancels it. 2m -1 plus the square root of 3i plus 1. Oh, look, dude, these cancel. Love
Nice.
that. Love that. 2 square root of 3i times m. I think that's z3. The third root. Ew, not
Okay,
imaginary
so-
numbers. And then we just multiply them together, right?
Yep.
Okay. So then, here, z0 times z1 times z2. That's going to equal 6m times... I think these were similar. Yeah, one of them's negative, one of them's positive. So that's negative... So there's a minus sign on the outside, whatever. -1. And then 2 square root of 3i squared. Becky says, well done. Thank you, Becky. This is a fucking bruiser of a question, but I like it. Okay,
There
4.
should be an M inside the square.
Oh, thank you. Yeah. You're right. So right. Okay, so this is 6m cubed. There's a minus sign. That's a 4. That's a 3. That's a -1. Cancel. 72m cubed, I think, is the final answer. Fembox says 6m, 2i squared of 3m. Yep, -2i squared of 3m. I agree. Becky, do you know the final answer? Is it also 72m cubed? Are we good there? I guess I could throw this in the chat. Chat could probably get this, honestly, right? I feel like I could.
I just have a strong feeling there's some other way to look at this where it's like you don't have to calculate. I mean, it literally said to calculate them individually, but I have a feeling that there's some way that you could have calculated the product without calculating each one. Like
Right.
Something to do with Vieta or something.
Yeah, someone did mention that Vieta's theorem or something. I had a sign mistake in my earlier work. Oh no, Fembox. Not the sign mistakes. Okay, I think this is correct. One sec. Let me see. I think I ran this through chat earlier. So here, let me go put this on ChatGPT real quick. All right, let's see. So ChatGPT said, good, -2 square root of 3i, 6m, 2 square root of 3i. The answer sheet only has prof as the answer. Proof? What? Okay, well, ChatGPT says it's 72m cubed, so I'm going to take it. Congratulations. Good job. Nice. Beautiful. Thank you, Math Fanatic, for like kind of helping me with that. I was seriously struggling.
Well, thanks for having me on, but I don't think I thought I was gonna come in with some kind of like a really cool like symmetry trick, but then it didn't end up working out, and I don't know how much I really contributed.
No, you did.
except
No,
for maybe a few things here and there.
you helped me out with the
but
minus
yeah.
signs for sure and stuff. Yeah, no, I appreciate it. Yeah,
Yeah. Minus signs, no problem. I can handle those.
good. Love that.
Okay, thank you.
You're very welcome. Thank you, dude. Awesome. Sick. So see, yeah, that's a great example of when chat can help me out because I'm struggling. I can do almost everything, math, physics, whatever wise, but then we get into like certain topics in math. Especially complex stuff that, oh man, it just boggles my brain. Sorry, how long is that question? I don't know. I mean, this question took us, I think, almost like 40 minutes. But that's because I was just fumbling the bag for a while, to be honest. It's really only a 2-question thing. I think someone in my chat could have solved it in like 10 minutes, but I wanted to be able to do it. Yeah. Complex analysis is my favorite topic. A beautiful... So complex analysis is the last class I took in my like PhD math. I have a PhD in physics, but that was the last math that I took in that like trajectory, was complex analysis. And I had kind of a shitty teacher for it, which was unfortunate. But it is beautiful. I remember like you integrate like around holes and like poles and like residue theorem, and all that stuff gets used a lot. That's why it's required in physics for you at least to go to complex analysis, because you need those tools. I never hit real analysis. I never hit discrete. And someone was asking me yesterday about, I think it was like a discrete math question. Where was it? Where was it? Oh, it was it this? No. Where was Equity's question, dude, on the discrete mathematics? Oh. We did it. No, it wasn't decibels. Oh, it was this. This was the question. Something with like equivalence relationships. If Equity comes back, I'll bring this up again. Maybe I'll get one of you math people in the chat to come up and explain it, because I don't know discrete math. But if he's here later in the chat, I'll do that one again. Let's see. The next one I have is from Indians fans. It looks like it's a physics question. Should hopefully be a little less painful. Thank you, Becky, though, for that question. No, I appreciate it. I learned. I relearned what this nonsense is. Of like dealing with things in the imaginary plane. You submitted the rest of the question? Cool. All right. Yeah. I'll take a look at it after this one. Let me feel good about myself doing some physics first. Physics is like the I don't know, it's like my self-esteem booster. I am tutoring, but you can also get tutored for free. Yeah. Anyone watching here, yeah, there's a website, actualdiscord.com/submit. Go to that website. It's right here. You can just type in like a username or whatever and drag and drop in a screenshot of any sort of question you want me to go through. What's useful, like help me help you, is anything that's like on your homework, anything that's on like a previous test or like a practice test coming up. If you show me a screenshot, that's all I'm asking you to do. I'll do the rest of the legwork. You just have to give me a screenshot. I'll be able to tell really quickly what level of math or physics or science or whatever you're in, and then I can help you learn it. Yeah, don't do JEE problems, please. No. I will attempt those, but I will toss them pretty quick, because JEE problems are just painful. Yeah, I don't want to do JEE stuff. That just makes me feel depressed. Yeah. Yeah, again, ChatGPT can do all the work, but you're not gonna become a better person from letting someone do all your work for you. It doesn't work like that. I mean, it's a great check. Like we did it today. You know, we went through this whole question and I didn't have a solutions for the last part. So I just had ChatGPT do it, and I checked to make sure that, you know, chat solutions were the same as my solutions. And they were. And so because they're the same, I'm pretty sure I did it the right way, you know? That's a great way to use ChatGPT. I did go to UT Austin. How do you know I went to UT Austin? Yeah, also, yeah. Mathematic Fanatic is saying does anybody know a way to do it with Vieta's theorem? I know Vieta's is a cool one, yeah. You shouldn't rely on ChatGPT, but it's a tool. And it's a very useful tool, for sure. It does show which position you're in the queue. So also, if you type so down there's a, oh wait, let's clear the queue real quick, because we did have some that we just did. So sorry. It says the queue is 6, but we just did Becky's. So here, let me clear the second. One second, I gotta type my code back in. I don't know why this SSL reset. Here, delete Becky's. Because we just did it. I'm doing Indian fans right now. So here, if we go to the stats, And then what I'll do is... Oh, 3 was just her showing me something else, so we can get rid of that one. So, in reality... no, sorry. Moses, I can do yours next. Because Becky's a continuation of the last problem. We're going to do Indian fans right now. Jebediah, I'm waiting because he asked yesterday, and I didn't get to him. So if he shows up, I'll let him hop. Yeah. Oh, does ChatGPT know the other way? Oh, we could, yeah, here, let me just cue that. Be like, is there another, I thought when you meant chat, you meant like chat in the chat. No, you mean ChatGPT. Okay. Is there another way? Okay, then let me turn on the fancy ChatGPT. I got you. Yeah, Moses, I'll get you right after Indian's question. Is there another way to do this with Vietta's formula or theorem? Okay. So we're gonna let that rip while I do this. Yeah, it's a fun problem. Okay. Here we go. A slide at a theme park has a constant slope so that it drops through a vertical distance of 7.5 meters while spanning a horizontal distance of 9.5. Let's draw some pictures. Love me some pictures. The link for the questions here. Yeah, here. I'll copy this one in for you as well. River. They go into like a private channel because otherwise people would start submitting like whatever just to get their shit on the, and it could get me banned. So I have to like kind of moderate them as they come in. But I'll post them there if you want. You had a quiz on this? Cool. So this is 7.5 meters down. And then this is 9.5 meters to the right. And then the coefficient of friction kinetic is going to be 0.67. Okay, so let's do that. Oh, here, let me try to draw a better box. Come on. You can get the box. There you go. That's a better box. And we know that UK is equal to 0.67. If the rider slides from rest at the top of the slide, what is their speed upon reaching the bottom? Solving this as an energy approach rather than kinematics. I like this. For the limit check, investigate what happens for V if the slide becomes extremely slippery. Yeah, cool. I'm assuming what happens is that if the slide gets really slippery, it's the same thing as it being in free fall. Like it's just dropping, right? Because nothing's resisting it at that point. Oh, someone saw the 6-7. Oh, god damn it.
No, God! No, God, please, no! No!
Okay. What I like to do when I have these types of situations... Let's draw all the forces, right? So, I know I have the normal force here. I know I have the force of gravity. Get a 6-7 sound effect. I don't know how long 6-7 is going to stay as a meme, though. What's the over-under? What do you guys think? Like, I give it, like, another week. I debated, like, doing some stuff for 6-7. I'm like, it's not going to be popular in another week. Do we think it's a long-lasting meme? Decades. I give it, like, 6 to 7 more days. Honestly, rest of the year? Wow, okay. Alright, this is physics. Okay, so force of gravity can also be broken down into components that, like, point into the plane and points that point down to the plane. The reason why I'm going to do this is what's called a coordinate change. We're going to rotate the entire frame. So I'm going to take this thing right here. And I'm going to paste it. But now what we're going to do is we're going to rotate it this way. Well, this would be the kinematics way to do it, wouldn't it? I think I still need this, though. I kind of still do. I'm going to show you why. Right. And I'll show you why I need it. Because I was missing one force here. Yeah. Some of the force is great. Yeah, there is an additional force. So since this thing wants to fall down, friction is going to oppose that. And so you're going to have a frictional force this way. Yes. I agree. I agree. Let's get to it, Radiant, though. I want to show it step by step. I don't want to just, like, dump an equation that no one knows, like, where the fuck it came from. Yeah. Patience. So this is kinetic friction. Pointing backwards this way, right? And the thing moves right. Okay, cool. let's do conservation of energy.
That's dope.
All right, we're gonna look at it can though. Radiant. It depends whether you consider the amount of force in the direction of the distance or the amount of distance in the direction of the force. Yeah, I'm gonna find the work done by friction, but I still need the Y component, right? Okay. So let's look at the different types of energies you have. All right. Energy. So we have kinetic, which is going to equal to 1/2 mv squared. But at the beginning, right, we say it starts at rest, right? So this is going to be equal to 0. Goodbye. Then we have potential. Okay. And that's going to be equal to mgh, which in this case, did they give us the mass? Maybe we don't need the mass. I think we don't need it. It's going to cancel. Okay, so that's going to be 7.5 mg. Okay. Now, because friction is involved here, I need to also consider what energy has been lost to friction. So this may be controversial, but I'm going to put a friction term here. It's technically work done by friction. And since this thing hasn't moved at all or done anything, the work done by friction or the energy lost to friction right now is 0. Okay? There's nothing there. Okay, great. All right. Now this thing is going to slide down to the right. So let's get another picture. This is like my in-between. I want to show like some things there. So now the box has gone all the way down. It is a lot like 6-7. You're right, dude. It is. Okay. So when it's here, right? Okay, let's get what the energy is. Here, kinetic energy, this thing is definitely moving, and that's actually what we're solving for. So this is 1/2 mv squared. I can call this like mv2 squared. I call it like mv1, h1. This is like, I call this like situation 1. This is situation 2. The reason why you want to do this in physics is a lot of times you'll have multiple situations, like 1 goes to 2 and then 2 goes to 3. Like there's an in-between. So I like to label it by the number. The potential energy here is going to be equal to mgh2, but at the bottom height is 0. So this is also going to be 0. And then work done by friction, the energy lost to friction. Okay, energy lost due to friction is going to be the force of friction dotted with, or like times like, I don't really want to say dot right now. I'm just going to say like times the distance. I know technically these things will be negative, but I want this to be a positive term over here. Because it's like, in situation 2, in the system, energy has gone to friction. Yeah. So, in this case, we got to find out what the force of friction is, okay? Force of friction is equal to mu k Fn, okay? We already know mu k is your guys' favorite number. It's 0.67. And then we got to figure out Fn. So Fn comes from our force diagram here, where if something is going down a ramp, gravity has components in the normal direction to the ramp and also in the parallel direction down the ramp, where this is theta. This is also going to be theta. If you want me to explain why that is, there's a little triangle trick. But in this case, FGY is going to be equal to mg cosine theta. Yeah, Fn is also normal force. I agree. And because I need this thing to not, like, fall down into, like, the ocean or something, I need the force normal that's pushing up on it to also equal the force of gravity pulling it down. I forgot work. I forgot G in the work done by friction. No, not yet. You'll see. Give me a second. So FGY is mg cosine theta, and that's equal to Fn. I'm going to show you, by the way, Radiant, why those two things work. Watch, you'll see. So, I told you it's 0.67. Okay. So this is going to be mg cosine theta, right? And then that's times the distance. Okay, so the distance we got to get to is like a little bit tricky here. So I could get the distance by the Pythagorean theorem. I kind of want to show it with like sine theta, honestly, though. Terminal velocity is when you have like air drag. I want to do it with theta because I want to show you guys. There's something cool here. So, okay, if this is the hypotenuse, this is also the distance that it travels in the direction of friction, okay? And in that case, we say that, like, sine theta is equal to 7.5 over h. Trigot entities, right? I could do the Pythagorean theorem. Totally could. I want to use sine. I want to show you why. It's kind of cool. Right, so this is going to be h is equal to 7.5 over the sine of theta. Or not h, sorry. Let's not call it h, sorry. Sorry, let me call it d. Sorry, I didn't mean to call it h. H is height, usually. Why do you enjoy math? It's a puzzle. I love puzzles. Puzzles are dope. Inverse sine. We don't need inverse sine because we know what the angle is. Didn't we know the angle? Did they give us the angle? Oh, we didn't get the angle. Oh. Oh, that's gross. Dang. No, I don't want that. We don't know the angle. Okay, let's get the angle. The angle is arctangent. That's what you just solve for. You totally can. Let's just solve for it right away. So, Radius says we won't need it. Okay, I'll keep it as theta. I'll keep it. So, tangent of theta. Yeah, or whatever. Let's just keep it. I think he has a point here. Yeah, we could use arctan. No, we totally could, Muffy. So, I could say that tangent of theta is equal to 7.5 over 9.5. Good. So, that arctangent of 7.5 over 9.5 is equal to theta. Yeah. I'm going to kind of show you why I don't think you need it. I think it does cancel out if you have the distances. Let's just leave this how it is. mg cosine theta. And then the distance it's going to go is going to be 7.5 over the sine of theta. The reason why I want to do this is because sine over cosine is tangent. That's pretty cool. No love for Pythagoras. I know. Poor Pythagoras is getting left out here today. He's getting left out in the cold. Yeah, I want to see if I can do this without theta. I think I can. Okay. Cool. So this total energy has to equal this total energy. So this total. Yeah, mg cosine theta. Yeah, watch. So this is 7.5 mg is equal to 1/2 mv squared. And then plus 0.67 times 7.5 times mg cosine theta over sine theta. This is why you can get away with not doing the angle. Cosine theta over sine theta is a. If you got a question, yeah, submit a screenshot. I'll do it down below. This is also equal to cotangent of theta, or you could say 1 over tangent of theta. Okay, here's the cool thing. Tangent of theta, we know what that is. Tangent of theta is equal to 7.5 over 9.5. Sorry, I forgot an equal sign here. Right? That came from the triangle. Yeah? So so 7.5 is on the bottom. And this is what I'm going to talk about, why also the gravity argument kind of works too. So you're going to get 1/2 mv squared plus 0.67 7.5 mg. Well, also, first of all the m's cancel. Let's just get rid of the m's just to make life simpler real quick. All right, mass goes away. I don't care about mass. That's why also they didn't give it to us. And then 1 over tangent theta is going to be 7.5 over 9.5. Right? Am I doing this right? Yeah. Six 7 shows up again. I know it does. So 7.5 G. Okay. Pretty cool. Watch. This will cancel with this, right? So then you're left with, let's move it over, right? So 1/2 V squared is equal to 0.67.
Nice.
Times G. Negative. Sorry, negative. Let me. I don't like putting negatives in the front. We're going to say 7.5 minus, or 7.5 G minus 0.67 times 9.5 G. Yeah? I think that's right. And then we got to square root it eventually. So multiply by 2. So V is equal to the square root. And this is going to be 2G times 7.5 minus 0.67 over 9.5 times 9.5G. Okay. M's got canceled. I know, poor M's. Cancel culture these days, man, I tell you. Cool. Nice, okay. Yes, thank you. Thank you, Femvox. Good catch. Yeah, I almost forgot the 2 in the last one. There's also a 2 here. Oh, let's see if we get it. Let me pull my calculator out. Dun. All right. So 2 times 9.8 times 7.5. Oh, 1 sec. No, come on, TikTok. Behave. 167. 9.5 times 9.8 is that square rooter. You get 4.71. I got 4.71 meters per second. I think, well, here. Okay, so this is where, you know, if one of us is right, one of us is wrong. I'm going to throw this at the ChatGPT just to, like, see what it says. And it'll be the judge. Here, tell it to solve this. You're lagging like a dog on YouTube? I'm sorry, dude. Am I? Golden calculator. Have to have golden calculator. Yeah. 1 sec. I mean, YouTube sometimes fucks up. Laggy. Let me get rid of the calculator. 1 sec. Yeah, let me see why we're lagging on Oh, I see. Yeah. You got a bunch of stutters? Yeah. Here, let me stop streaming on Discord real quick. Sorry, River, you can watch the stream if it's... Because sometimes Discord takes too much bandwidth. It's okay now? Oh, okay. Alright, whatever. You can see the stream as well, River, maybe, yeah? Just because Discord takes so much resources. Okay, cool. Dope. ChatGPT is judge, I'm out. I just want to see what it got. Wait, where is it? ChatGPT got 4.7, which I think is what I got. No? Oh, we gotta zoom in. Wait, where did my answer go? Excuse me. That was, wait, this was the last question we did. Oh, did I just lose my question? Where are you? One sec. Sometimes. Okay, there we go. Yeah, so 4.7 is correct. Nice. That's a cool calculator. Thank you. It's 5 a.m. Where are you at, Radiant? Tell us, dude. I agree. Yeah, the key thing here is that like work done by friction is also seen as like energy, and specifically like change to mechanical energy. Okay, so they also wanted to see the limit check that if mu k went to 0. So, India. Okay, welcome, dude. Welcome, Beta. I've heard that Beta means like brother or something over there. Here in the U.S., calling someone Beta is like.
Offensive. Oh, did someone get baby voice going? Thank you, Zach. Okay, now you're gonna hear me in a high-pitched voice for like 30 seconds because someone bought a filter on my Twitch. So this was square root of 2g. Remember this was the height, okay? And then this was minus 2 mu k. And then this was the length times g. Right? That's actually pretty cool.
So if mu k goes to 0, right? If it gets really, really slippery. You say bye for brother? Okay, cool. This goes away. And look that you get the velocity is equal to square root of 2gh. This is the same velocity for something that's just in free fall. You can see this from kinematics too, by the way, right? Let's say you do this basic equation. X equals x naught plus v naught t plus 1/2. No, I don't want this one. Sorry, not with t. I want this one. V squared is equal to v naught squared plus 2a delta x, right? We remember this from kinematics. So if something's in free fall, just being dropped, v naught 0. Acceleration is g. So you get v squared is equal to 2g delta x, where delta x is going to be the height. And look at that, v is just equal to square root of 2gh. Yeah. It's the same thing. So yeah, if it's really slippery, it looks like a ball that just got dropped, and it's free fall. Now math is fun. Nice. All right, good job, guys. Good question. The timeless equation. It is timeless.
Well done.
Clap, clap, clap. Yeah, nice. Good question there. I can definitely do circular motion, and that's actually the next question that got asked. So, Muffy, you're in luck. Because Moses has literally asked me a circular motion question. And that's... Yay. Yeah, nice, right? Yeah. This is a great example. Again, if you want help, be like Moses. Be like Indiana. Be like Becky. And send me a screenshot. Because, yeah, now I'm going to mark that one off. Because we did that one. Sorry, where is mine? Also kind of like fighting a cold. This is annoying. Where is... Oh, there it is. That's what I need. Okay. Alright. So, we're going to get... Indian fans, we did your question. So, put that one out. We're going to do Moses's. And then we can continue on with Complex with Becky if we want. Or if somebody else... How do you send screenshots? Good question. So, there's a website here called... if you just go to actualdiscord.com, it should take you here. You could also do actualdiscord.com/submit. Either one of those should work. But this is the web page where just type a username so I know whose question it was, and just drop a screenshot in, and then it gets added to the queue. Aquamanian says, "You go, bro. This is actually productive rather than scrolling around getting brain rot." Yeah, I know.
That's dope.
I keep telling the people that come here and like troll me, they're like, "Stop yapping, bro." I'm like, "Keep scrolling, man, dude." I hope you enjoy the feet pics. Gonna get you really far in life. Okay, you had delay. Cool. You thought of a fun one, River? Yeah. So, yeah. Just go here. Actualdiscord.com. If you have a fun one you want us to go through. Okay, cool. You're fixing re-uploading? All right, so here, you want me to clear that one for you real quick? I'll just clear number 2. Actually, I'll clear Jebediah unless he comes back. There you go. So there's actually technically only one question in the queue right now. And that's the one we're doing right now. Okay, what is the maximum speed with which a 1,200 kilogram car can turn around a radius of 90 meters on a flat road if the coefficient of friction between the tires on the road is S? This is a great question. I've done videos on this on YouTube. I will explain it now. Well, here, I'm going to show people if they want to, just a little shameless promotion here. But if you go to our YouTube channel, and you go here to like search, and then I think if you just type in centripetal, here we go. Here's a whole video I made with some Ukrainian animators that I went over like how centripetal motion works. And this is the cool thing. So here, actually, you know, I'm going to steal this video just so I can like show you like some of the what happens. Okay, so anytime something moves around in a circle, okay, what ends up happening is here. Let's get past this stuff. Yeah, this was like the question, but let's talk about this. So anytime something moves around in a circle, it has a speed, right? And let's remember that speed is a scalar. It's not a vector, right? It does not have direction. Okay, so if something is moving around at a constant speed in a circular motion, we can say, cool, speed is constant. However, velocity will not be, because velocity has a direction to it. So in this case, the velocity changes as you go around the circle. Because, for instance, here at the side, well, here, did we show it? I hope we showed it. Like, how, there we go. Okay. This is the velocity. See how the velocity direction is always changing? And change in velocity over change in time is equal to acceleration. And so acceleration always points to like where the velocity is changing to. So for instance, when the car is down here at the bottom, the velocity is pointing to the right, right? The speed is pointing to the right as well, but speed doesn't have a direction. It wants to start going up. So that means the changing velocity, which is the acceleration, has to also point up. So I'm waiting for myself to like talk. Come on, keep going, keep going. Okay, there we go. So this is the acceleration. The acceleration always points perpendicular to the velocity, which means it always points inwards. And then what we say is that in order for there to be an acceleration, because F equals ma, you have to have a force. So there needs to be some sort of restoring force that pulls you in. In the case of cars with tires, it's friction. So friction, you can see here, this is really cool. On like an F1 car, it like moves back and forth. Like the friction is like just oscillating and wobbling like crazy. The roller coaster question is the typical one that eventually comes up, but we'll get to that. But yeah, if you want to watch that, go to my YouTube. I have a whole video on it, but we're going to do this one for you just right now. Okay, so let's say we got a track. I got a car. And here, let me make this a solid car. This is car. Car is moving, right, with a velocity in this direction, but it has an acceleration in this direction, right? Because the velocity, when the car moves like over to here and like rotates. So here, actually, let's use like let's use a circular car, just so you can kind of see what happens. There we go. Circular car. It's a bubble car. So when the car, for instance, moves up to here, now the velocity will be pointing this way, okay? But in order the velocity to go from pointing up to pointing left, that means the acceleration had to like move it to the left. So that's why the acceleration is to the left here. Here, now the thing eventually wants to start going down. So in this case, acceleration here had to point down. The velocity had to change from going to the left to going down, and changing velocity is acceleration, so that means acceleration is down. You eventually do this in a circle, and you see that A always just points inwards. So this is like what I call like the top view, okay? And what we know is that in order for there to be an acceleration inwards from F equals ma, that means there must be some force that's pulling inwards. The velocity is always tangent to the circle. Yes, if something's moving around in a circle, the velocity, which is the change in position, is always tangent, which is, yeah. You can show that also with like calculus. You could do like derivatives of something in polar coordinates and show it, but it's okay. So here. So we know there must be like some force pulling it on the inside. Okay, so I'm going to say like that is what I call the centrifugal force. That's kind of like a weird thing to talk about. So we're just going to say that there's a centripetal acceleration inside, and then we'll talk about what force provides that acceleration. Now let's look at a side view. Okay, so side view means instead of looking like down on the car moving around the track, I'm going to like pivot myself down looking at the back of the car as it moves around in a circle. So you can think about this, for instance. We start to look here. I'll show you like kind of how this works. Yeah, I'll explain. The centrifugal force isn't real. Or the centripetal force isn't real. One of them isn't real. Yeah, the tip of a windmill. Yeah, that's a great one. Okay, so watch what happens. So instead of viewing from the top, what I'm going to do is I'm going to like shift my vision so that now I'm viewing from the side. Okay? Does that animation kind of make sense? Technically they are, Dan. But this is an ideal case. Okay. So now I'm looking at the car this way as it goes like into the page and out of the page like this, right? Okay. So let's consider what the forces are on this, all right? This is going to have a normal force pointing up. It's going to have a force of gravity pulling it down, okay? Now we got to think about other forces in the x direction. I know, since this thing, again, was moving around in a circle, in order for it to not, like, fly off the track, it has to have a restoring acceleration that keeps it in a circular motion. So that means here, I have to have some sort of acceleration that's pulling it inwards, okay? And any sort of acceleration also has to have a force. You can't have acceleration without forces. And so you ask yourself, well, what force is doing that? It turns out, and this is very counterintuitive, it's the force of friction. Friction is the force that pulls you in towards the center. And this should kind of make sense because friction is the whole reason your car doesn't fly off the track. Like the whole reason you're able to turn is that friction is able to provide enough force on the towers to pull you in. This is circular motion. Yeah. Okay. So now once we're at this point, all we do is do sum of forces, right? So sum of forces in the y direction, that's going to be Fn minus mg. Cool. And then we do sum of forces in the x direction. Now in the y direction, this thing needs to not move up and down. So sum of forces is equal to mass times acceleration in the y direction. Acceleration in the y direction is 0. Yeah, flying drones. Yeah, that's another cool thing. Okay, let's look at the force in the x direction. There's only one force. It's the force of friction. Okay? I'm going to call going to the left positive in this case. And this has to equal to the mass times the acceleration in the x direction. Now, the acceleration of this thing in the x direction is the centripetal acceleration. Okay? Because that's the acceleration responsible for something moving around in a circle. So instead of saying max here, I'm going to say ac. And you learn in physics that AC is equal to v squared over r. So it's equal to what's called the tangential velocity. So that's like the speed that you're going around the track, right? Without any direction. Also squaring gets rid of directions. Divided by the radius. You got Master Chief coming out? Nice. Okay. So, and then let's remember, force of friction is equal to mu kFn. Yeah, formula sheet. Yeah, don't rely too much on those, dude. They sometimes take them away, especially in college. Okay, so this goes in here. Force of friction is mu kFn. And then the cool thing is, from this, I know that Fn is just equal to mg. All right? So now we're left with mu k mg. Yeah, this is kinematics. Or, sorry, dynamics, I guess, technically. Is equal to mv squared of r. This is something that's super dope. Notice that the mass is going to cancel out. I don't care how heavy the car is. All I care about is the coefficient of friction, how fast I'm trying to go, and what my radius of curvature is. So let's look. Well, that was actually kind of part of the question here. They said, is the result independent of the car mass? It is. Yes. I agree, David. Yeah, yeah, that's like the real world thing. Okay, and they're talking about what's the maximum speed. Okay. So the maximum speed is going to be like the maximum force of friction that can be provided. So technically this isn't a mu kinetic. I take that back. This is a mu static. Even though, like, I know the wheels are moving, the key thing is that friction is providing enough force such that this thing doesn't move, like, away from the track as it, like, flies forward. I do need to drink water. Thank you, Zach. Yeah. So I always, like, try to think about this, like, if this car just had no, like, slippy tires, this thing would just, like, fly forward, right? And as it flies forward, in, like, this frame of looking behind the car, you would see it deviate from the track to the right. Yeah. Okay. So, you're solving for... Yeah, if you speed up, it'll drift out, right? Because this is the maximum amount of frictional force that can be provided. Yeah, dude, 6 weeks are nuts. I taught a 6-week physics course at UCLA, and, dude, it was brutal. 5 days a week, hour and a half every day. I had to give tests every 2 weeks. It was brutal to teach it, as well as to take it, I'm sure. Okay, so it's mu s gr, right? Mu s gr. The m's canceled. And then square root of this is equal to v. Cool, right? So, mu s was, what do they give it? Is everything 0.67 these days, dude? No, 0.65. Oh, damn, so close.
Oh, no.
Yeah, why is it a thing? It's a moneymaker. The university just makes fucking bank, dude. Bro, I had like 110 kids in my class. It was all online, too. I think they paid $3,000 a person. So what is that? $300,000 went to the university, and the university didn't have to pay for anything. Like, I paid for my own electricity. I paid to teach it. Like, the university had zero overhead. Besides, like, I don't know, like Becky and fucking HR, like, you know, answering questions that students don't ask or something. I know, yeah, dude. I got paid $7,000 for that. UCLA took 300. Or I guess they took 293. But whatever. It was a cool experience. I appreciated it. It was fun to teach at the collegiate level, especially online. I'm already pretty good at teaching online, so it was fun. Okay, the radius of curvature is 90 meters. Cool. Okay, so we should have an answer for this. Let's just get it. Yeah. Calculator. Square root of 0.65 times 9.8 times 90. So you get 20... Yeah, it's 24 with sig figs. I agree. 24 meters per second. I agree. Which I think that's around 60 miles an hour. Is it? I used to know the conversion in my head real quickly from meters per second to miles per hour. I can just do it real quick. 24 meters per second, 2 miles per hour. Whatever. Yeah, 54 miles an hour. Yeah. Nice. Yeah, because what's 60? 60 is 27. Yeah, that's the one I remember. Yeah, anytime you see 27, that's exactly 60 miles an hour. Nice, beautiful explanation. Cool, great. Does that make more sense to you, OG Moses? Does this not hurt as much? I hope. Yeah. Some good stuff. Yeah, it does make sense. Sick. Awesome. Yeah, I gotta practice some more. Yeah. So, again, if you want, I would highly recommend, especially if you're doing any sort of circular motion stuff, go do the question in my YouTube. On my... Here, I'll send you the link for it, too. But, yeah, if you go here to, like, centripetal... This question comes up all the time on tests. So, this one. It's a 3-minute video, but this question about the roller coaster and how heavy the person feels at different parts of the roller coaster. And there's also, like, what's the minimum speed? Like, this combines, like, kinetic energy, potential energy. Depending how mean your teacher is, this can definitely get covered. I'm speaking as someone who's written tests at the college level for this class. This question gets asked. So you should definitely do it. Where's my chat? Accidental send? Would you accidental send me kissy faces? Where's my chat? Yeah. Here, I'll post this link in here. Yeah, exactly. What's the minimum velocity? Yeah, exactly. Yeah. That's a very, very big one. Yeah. Look at that. That's a big one for centripetal motion. You just had the roller coaster one. Yeah, surprise.
Surprise, motherfucker.
Yeah, that question gets asked a lot. A motorcyclist at a circus. Yeah, that's another one. And yes, Snazzy, I highly recommend taking STEM classes, especially if you're a STEM major and you need to know how to do STEM stuff. Do not take it over the summer. I don't care how smart you are, unless like you already know the class and you're just trying to knock out the credit so you can get to the next class. It's very difficult to learn like completely in 6 weeks. It's very difficult for me to teach in 6 weeks. And I'm someone who's been teaching for like 15 years. I have a PhD in this shit, and it's still hard. So I can't imagine how hard it is as someone who's never seen it to learn it in 6 weeks. And I guarantee you, I put a lot more effort than most teachers do into like summer courses. So please, if you have anything like critical for your degree and it's in STEM, do the full 10-week like semester course or quarter course, whatever it is. Don't do it over the summer. Yeah, I wonder too. Again, if you're just knocking it out, say you're a pre-med and you just need the physics credit for like whatever to like get to the next step, you want a challenge and you want to really test yourself, cool. But if you're a physics major or you're an engineering major or you're in any sort of major where like you're going to actually need the physics you're learning, I do not recommend doing it over the summer. Just don't. Yeah, dude, it was brutal. The last week of the Physics 1 course was like the first week of the 8-week. Yeah, and then you're taking something else concurrently. Yeah, don't do that.
Oh no.
No. Yeah, don't take 2 courses that overlap. Yeah, the true reality. Yeah, no, I got you, dude. Yeah, I mean, I'm not gonna sugarcoat shit. Like that's just what life is. Do I teach Orgo? Not really. I can teach Chem 1, Chem 2. Orgo, I took in like high school. I don't know how much of it I remember. And a lot of it is like really particular reactions and stuff. I mean, I like the mechanisms are cool. I like the kinematics. What is it called? Kinetics? Kinetics is cool, but yeah, a lot of Orgo is memorizing specific things that happen and like nomenclature and naming, and it's just gross. I don't teach it. Oh, nice. 18 miles per revolution. Yeah, that's another circular motion thing I can go through. I mean, the quick answer for that one, before I move on to the next question, I definitely teach Calc 3. Yeah, I love teaching Calc. I'll teach Calc all day, bro. Okay, if you have something that is moving at an angular speed omega, then it moves at what's called like a linear speed, v, which is equal to r omega. Yeah, v is equal to r omega. So you notice that the linear speed depends on r. Depends on how far away you are from the center. Okay? This is like important. And there's a whole explanation for where it comes from. It kind of comes from, so velocity is equal to change in distance over change in time. And then distance around a circle is equal to 2 pi r, right? And then this is still delta t. And then, what is this? Omega, angular frequency, is equal to radians divided by period. Yeah? And so this is the same as this, right? So the period for you to go around once is the same period for the circumference. So what is this? You get period is equal to 2 pi over omega, which is also equal to 2 pi r over v, if I rearrange this for delta t. So this cancels, sorry, this is 2 pi, not 2 omega. Sorry, 2 pi over omega. Yes, I think I got this. The pi's cancels as well. And so you get v is equal to r omega. Yeah. So that's the cool way if you want to really look at it. That's another way to connect linear velocity and angular velocity. Yeah, I'm gonna watch this. Good. Yeah, watch up, dude. DM Scrader. All right. Next question is from Clickbait. Okay. Are you gonna hurt me with this clickbait? This looks like damped oscillations. So this is more physics. But again, I do everything. So if you want to ask a calculus question, you want to ask a chemistry question, I can help you with that too. It just tends to come in waves, like what questions we solve. Sometimes we solve physics. Sometimes we solve... Oh, then let me give you a coin, Moses. Yeah. Yeah, as an added bonus, yeah, if you're in our Discord and you ask questions, you get credit for the questions you ask. And if you get enough points, I buy you a gift card in like Fortnite or PlayStation, like whatever gaming stuff you want. It's part of our whole nonprofit, which is using traditional like gaming streaming platforms, so Twitch, YouTube, whatever, TikTok, to encourage gaming kids to like do well in math and science. It's a fun little thing. You want to read about it? I should put on the website down there like what our official nonprofit website is. What's up, 1K? 1K knows about this. 1K, how many gift cards have I bought you in the last 2 years? Yeah. This isn't so bad, I think. All right, cool. Let's do it. All right. Yeah, equilibrium can be kind of tough. So Fembox, they only show up in a channel that I can see, just to prevent people from like uploading feet pics and then it just being public on my Discord somewhere. What I can do is that like every time I have a question, I can because I have to like moderate them, I can post them in the stage chat there if you want to see them. Maybe that's like a way to do it. I could try something automatic when I have more time to code. Yeah, 1K is like, you bought me like 4 gift cards. Yeah. I bought a Nintendo Switch 2 for someone a couple weeks ago. We had like a virtual summer camp where students like did video game competitions, math competitions. We had a chess tournament. We had a talent show where one of the students memorized the first 79 digits of pi and like did it on a video. It was super cool. So it's like a blend of all these fun like gaming and educational challenges, and one of the kids won a Nintendo Switch. Yeah, it's real. People are like, this must be a scam.
That's dope.
It's not a scam.
Ma, you done messed up, Aaron.
Okay. Yeah, exactly. Yeah, 1K knows what's up. Yeah, it was a Nintendo Switch 2, and then the 4 runners up all got $10 gift cards. Yeah. Or 5 runners up, right? Because I think I picked top 6. Yeah. Do you know any games that have you do different equations for crafting and stuff? Like Minecraft? I think there's kind of equations for that. All right, let me see this real quick. Let's do this one. My body is fighting something. Sickness-wise. So I'm trying to push. Yeah, it's amazing. Yeah. I'll post this. I haven't had much time to really update the announcements in the Discord. I will do that this week, because I know a lot of people are kind of like waiting like gold. What's going on? I've just been on a mad push with streaming right now to get us to like full monetized level on YouTube, and I think we're gonna get it this week, which I'm so happy, because once that happens, finally YouTube starts paying us for these videos. I put out like 1,000. I have like 1.4 million views. I haven't gotten paid a fucking dime for it. And it's not me getting paid, it's like the nonprofit getting paid so that I can buy more kids gift cards. So we're close. All right, a fixed damping constant beta that is driven by a sinusoidal force of variable frequency omega show that the amplitude of the response is maximum when omega equals this. Note that so long as the resonance. Okay, so this is the classic way this works. Let's say for not let's say for an undamped oscillator. You know that for a spring, let's say for a spring here. Your aim got better? Nice. I need to get back into gaming. It's been a while. I've been in between jobs, so I'm trying to like figure my life out. Let's say something is oscillating on a spring, right? You know that there's always a restoring force on the spring. that's going to be equal to f is equal to negative k delta x. We do need equation 5.71, but I think we can rederive it here anyways. Right? Clickbait? I don't think it's that bad. So, and this is the only force in the x direction for something oscillating on a spring. Yeah, dude, a Chromebook is trash. This is also equal to mass times acceleration. Okay, so here's something. This is something really cool here. So watch. So we're gonna say, and I gotta remember how this works with the negative. I think the negative does matter, right? You're not a fan. Uh-oh. So negative k delta x is equal to mass times acceleration. And instead of delta x, let's say that it's just x, and let's fix the equilibrium at x equals 0. So I can just say this, okay? If I then move the m over, okay, we're going to get negative k over m times x is equal to a. And let's remember from physics what acceleration is. Acceleration is the same thing as the change in velocity over the change in time. But velocity is equal to the change in position over the change in time. So if I plug this into here, you now get d squared x dt squared. This is a very, very famous equation called the wave equation, which has a solution whereby y is equal to, I think it's a sine kx plus omega t. But actually, I don't really want the position, right? No. Sine omega t. Let's just do this. Yeah. So what this is called a differential equation, because look, you have the variable x and you have the second derivative of the variable. We can check this. So watch, let's check this. So and sorry, let me call this x. Sorry. X is equal to a sine omega t. Then dx dt, we know from taking derivatives, is going to be a omega cosine omega t. So again, derivative of sine is cosine, but then you have to take the derivative of what's inside, so that pops out an omega. And then d squared x dt squared is going to pull out another omega and another derivative. So that's going to be negative a omega squared sine omega t. Yeah. Why is this useful in real life? Waves are everything, dog. Yeah. This shit comes up everywhere. The wave equation is a super useful thing for solving any sort of oscillating system, which most things in the world are oscillating systems. Like your happiness is an oscillating system. I mean, hopefully it has ups, you know, not just downs. Okay. Sine omega t. So that's what x was, right? And then watch what the second derivative was. D squared x dt squared, right? So this is equal to negative a omega squared sine omega t, okay? So this statement is true for this solution x, right? This will cancel with this. Provided that omega squared is equal to k over m. And the other way we write that is omega is equal to square root of k over m. Okay? This is called the natural resonant frequency. Okay? So this is the frequency that something with a restoring force that is proportional to the distance will always oscillate at. And it comes down, this is calculus. I mean, it's technically differential equations, but it's very cool where this comes from. Now, this was an undamped, undriven oscillator. We're dealing with something a little bit different, which is a damped oscillator. Okay, so I got to remember the damped oscillator case. I think it comes down to writing the same, we just write a force equation and then we start taking derivatives. And then it's a trickier differential solution because it's not homogeneous, right? Okay. Okay. So again, let's pretend there is something oscillating, right? Back and forth, okay? But in addition to there being a restoring kx, there's also a damping term, okay? So in addition to having negative kx trying to pull you back, you also have, I think they call this beta. Negative beta, right? Do we just call this negative beta? I want to say we just call this negative beta. Okay. And then, let me see. You gave me another equation, clickbait. Let me see this. Yeah. Beta times V. Does it depend on the velocity? Let me look that up, sorry. Damped harmonic oscillator force equation. You might be right, Fem. Ah, it is dependent on V. You're so right. Yeah, it's CV, which I think we're going to call beta V. Okay, cool. All right. So yeah, this is beta V. Yeah, this is the drag term, right? Someone was asking me about like terminal velocity. This is the type of term that gets you like a terminal velocity. It's a drag term because it's dependent on how fast you're going. So this is also why, for instance, when you're driving a car over a certain speed, you start to really significantly lose gas mileage because the drag force of the wind starts ramping up like crazy. Yeah, you call it gamma. Yeah, that's another way to refer to it, Zach. Totally. Yeah. So, yes. In this case, our force equations is I'm going to have like kx, negative kx minus beta v is equal to negative ma. Sorry, it's equal to ma, not negative ma, sorry. Yeah, there's the equation we could use. Yeah, this is eventually, I think, what we want. Oh, they just want to show that it's max. Okay, well, this is just plugging shit in. I want to show where this comes from. It's kind of a cool derivation. Because the cool thing here is velocity is the first derivative of position, acceleration is the second. So you can write it this way. So actually, if we move everything over, you get m d squared x dt squared, right? So this right here was the acceleration term, plus beta dx dt, right? Plus kx is equal to 0. And correct me if I'm wrong, this is beautiful actually, right? Because the solution we know for this one is just it's e to the alpha x, right? I think it's what I say. I say x is equal to e to the alpha t, right? Yeah. We assume this is a solution such that dx dt is just equal to alpha e to the alpha t, and then d squared x dt squared is equal to alpha squared e to the alpha t. So this is important. This is in calculus. You learn about how to take derivatives of e to the x. Derivative of e to the x is always just e to the x, but then there's a chain rule of like what was up in the x. In this case, it's alpha t, so an alpha has to come down every time. Okay, so now I can solve this. So this is m alpha squared e to the alpha t plus plus beta alpha e to the alpha t. I think so. We'll see. Plus k e to the alpha t is equal to 0, right? So all the e to the alpha t's go away. I don't need any of these. And this is super cool. Instead of alpha, I don't like alpha. But I'm already using x. Can I just use y? Can we use y? Let's just use y, please. Okay, cool. So my squared plus beta y plus k is equal to 0. This is a quadratic equation, right? Whereby I'm going to do x is equal to negative b. Or sorry, y is equal to negative b, so negative beta, plus or minus the square root of b squared, so that's beta squared minus 4mk all over 2m. Okay. And you were gonna get to that. I think there's also a term on it. No. This works, yeah? Yeah, okay. So this is where you have the arguments of damping, right? Whether you have critical damping, underdamped, or overdamped, underdamped, or critically damped, right? And I think the maximum amplitude occurs at... is that critical damping? Let me read up on this. Sorry, one sec. It's on. I'm reading this on Hyperphysics real quick. Let me show you guys. Where is it? This is it. Yeah, this is the damped harmonic oscillator. Okay. Yeah, this is right. This is this. Cool. And I think. Okay. Where's the one I want though? Okay, here we go. This is the omega. Yeah, the characteristic equation. Yeah. I think we want the underdamped case, right? So critically damped means overdamped means it doesn't even oscillate. It just slows and just dies. Critically damped is the time for one oscillation, right? Overdamped is it takes forever to get there. And then underdamped, I think, is what we want. Yeah. Okay. Okay. I think we're underdamped. And underdamped is where you have imaginary solutions because you need it to keep oscillating. I can do linear algebra, yeah, for sure. So that's when beta squared is less than 4mk, right? And then is there something we call this? And then wait, where's this factor of 2 coming from? Yeah, you're right. Oh. I call this 2 beta. Is that what I call this? Oh, is that the trick? Yeah, I think I get why he's saying this. This is 2 beta. This is 2 beta. So then this is 2 beta. This is 4 beta squared. Okay, I see. Okay, yeah, this is much nicer because watch, the 2's cancel. So you can pull a 2 out of this. 2's. Okay. So now you get y is equal to negative beta plus or minus. You're so right. This is beta squared minus mk over m. Okay, right. And this is, okay, so omega naught is this equal to the square root of k over m. So omega naught squared is equal to k squared over m squared. And do I end up like pulling that out? I think there's also another m term in there, I think is what happens. It's just k over m. Yeah, sorry, it's just equal to k over m. Thank you. But then, how's there another m in here? Oh, John Taylor has it? Yeah. Oh, I think I see it. Negative beta over m plus or minus the square root. Pull the m inside. That's beta squared over m squared minus k over m. There we go. Okay, so negative beta over m plus or minus the square root. Beta squared over m squared minus omega naught squared. Okay, and then, yeah, I think they define is, instead of just being 2 beta, it's like 2 beta m. Why are you allowed to call it 2b? Because you can just say that the damping coefficient has to be related to some constant b, and 2 is another constant. It's just a number, right? So this will just mean whatever my solution for beta is, has like an extra 2 on it. You just have to divide out, but it's a constant. So you're totally allowed to just call it whatever you want, as long as you're multiplying by constants. And the mass is also a constant. So I think they call this negative 2 MB is what they do. Yeah. Because then this would go away. This would go away. And I think you get left with this. You get negative beta plus or minus the square root of beta squared minus omega naught squared. And this is kind of like the preferred solution, the way to do it. Okay. Yeah. Okay. And then when you have these types of solutions, this ends up equaling some like negative e to the negative beta t, right? This is the damping part. And then it's a cosine omega 1t plus b sine omega 1t. Where I want to say omega 1 is this. So omega 1 is equal to the square root of beta squared minus omega naught squared. Or wait, no. If it has to be less than it, then it's equal to omega 1. Omega naught squared minus beta squared. Okay. Anyways, the original question doesn't require this whole derivation. This derivation is cool. But if we want to just look at it, and let's see what... Yeah, you had the particular solution here. Yeah, okay, cool. We're doing some physics here. Yeah. This is the solution you do for it. Yeah, into the equations of motion. Sorry. And then, yeah. So, see, B was defined as 2m beta. I see. Okay. And then, where was this other equation we had that we were checking out? Wow, what's up, Obi? Thanks for the raid. Yeah, no, I have a PhD in physics. I've definitely done this before. I don't remember it. What's up, Obi? Yo, big shout out to Obi. Thanks for the raid, dog. Obi's another one of our awesome Twitch math streamers. He lives on the other side of the pond though. He's in England. So everyone's doing good. Yeah, we're doing a little bit of physics here. Okay, I think here they just wanted to show that the intermediate value theorem. Yeah, I mean I have a video on it. Here, if you want to see it, I'm gonna send it to you. Or it's on my TikTok too, by the way. I think it's one of my top TikTok videos. The best way I say I can help you is for you to submit like a screenshot of a question that you want me to go through. Let's say like an intermediate value theorem question. So then I know what you need to learn. But I think I've literally done this question. Where is it? Here we go. This video right here.
Here's how to make sense of the intermediate
value theorem. This video has like fun memes and stuff, but it'll explain like where it comes from, where that big formal definition is, and then also I think I go through an example on like how to do it. So while I'm working through other questions in the queue, please like check this out. Also, if you're on YouTube, you can just go to my YouTube and type it in as well. If you go to YouTube, where's my channel? Really enjoy. Oh, dude, thanks for the €2. Look at that, dude. We got some donations. That's fucking dope, dude. Thank you, man. Yeah, intermediate value. Just click here. Just search on here. And then here's the IVT. I have a video on it. It has 13,000 views on it. This one did pretty well. And then I also do the mean value theorem and Rolle's theorem, because that's another cool one. So yeah, please check those out. Okay, so I think we solved this one. If you want to show its maximum when omega is equal to this, so you're just looking for this to blow up. Right, sorry, let me show. Sorry. If you're looking for this to be maximal, you're just looking for the bottom here to be equal to 0, right? Because that's when the amplitude just like goes to infinity. So if you plug in this into here, you're going to get omega naught squared minus, and then this is going to be omega naught squared minus 2 beta squared, I guess, right? We square that. But then that's all squared as well. And then plus 4 beta squared omega squared. This cancels with this. And then you get 2 beta squared. No, you're not the only 9th grader here. No, don't worry. This is advanced, right? This is college level. But like earlier, man, I was doing, what were we doing earlier? I do like some pretty basic stuff. Yeah, so we were doing geometry here. This was a geometry problem the other day. This is more physics. This is all kind of, we have had a lot of physics lately, but we do all sorts of math. This was Doppler effect we did. dAdW equals 0. I think you just have to show it blows up. Do you not? Yeah, don't worry. This is advanced. But like if you watch, you'll learn some stuff. So if this cancels, you get negative 2 beta squared squared plus 4 beta omega squared. Oh, change square root of 2 to 1 plus I when it's imaginary? Okay. I feel like I needed another omega squared in here. Oh, but omega squared is also equal to this. Oh, watch this. Yeah. So this is also equal to omega naught squared minus 2 beta squared. Yeah? Okay, cool. Does that work for the units, though? Oh, this is 4 beta squared. Oh, thank you, Pietro. I appreciate the support, dude. That's fucking sick. Wow, we got 2 donations today from Europe. My European friends, dude. Holding it down. Pietro, tu sai che abbiamo lo stesso cognome? Mi chiamo Giovanni Rossi. I gotta remember my Italian. I have no one to speak it with, so I forget it so easily. Okay, 4 beta squared, and then this is omega naught squared. Minus 2 beta squared. Let's see if this cancels. I think it does. So 4 beta squared plus 4 beta squared omega naught squared minus 8 beta to the 4th. Okay. So then, that's 4 beta squared omega naught squared minus 1, right? Because 4 minus 8 is negative 4. I'll put that there, and then there's that. Would Grandmama give you a tap on the head? Maybe. Where is the root of omega? That comes from this. Omega is equal to the square root of omega naught squared minus 2 beta squared. Aiken's right. I have an exponent wrong. 4 beta squared on the 4 beta to the 4th. 1 sec. Wait. 4 beta squared omega squared, right? 4 beta squared omega squared. Then omega squared would be omega naught squared minus 2 beta squared. So then if you distribute that in, shouldn't that be 4 beta squared omega naught squared? And this should be minus 8 beta to the 4th. Good luck, dude. Good luck, yeah. Oh. Thank you. This is 4 beta to the 4th. Thank you. Thank you. Thank you. Yep, you're good. You're good. Appreciate. Okay. Okay, so now that's 4 beta squared omega naught squared minus 4 beta to the 4th. I think I wanted this all to equal to 0, right? If the denominator is equal to 0, the amplitude should blow up, right? Teacher, my girlfriend is pregnant. What's the solution? Be a father. Don't run out on your kid. Okay. Omega naught squared. So this occurs when omega naught is equal to beta squared. Is that the solution, when omega naught is equal to beta squared? I think so. Maybe we do have to do the derivative. Right, because I don't think the denominator will actually be 0. Yeah, okay. I was just hoping it would blow up. Alright, fine, fuck. Sometimes this happens. Alright. I'll do it again. Okay. Let's call this y. For instance, right? And I want dy dw to be equal to 0. Because in order for something to be maximal or minimal, I need the critical point, which is where the first derivative is equal to 0. Plot it on Desmos. I mean, we could do that. That's cheating, though. Isn't that cheating? No? The cool thing here is we have everything just in terms... You can do d omega squared. Okay, true. Okay, I like the change of variables. That's a good idea. So yeah, let's just say that let's just say x is equal to omega squared. Okay, so now my new equation is omega naught squared minus x squared plus 4 beta squared x. Yeah? We're not doing implicit. No. You look so handsome and intelligent. You say, dude, everyone's single, bro. What? Have you seen the birth rates, dude?
Obviously, don't
They're
go
terrible.
and do that.
Hey, you do whatever you like.
We
You
can't
single.
condone anything of the sort.
No, we can't.
Okay. All right. I want dy dx be equal to 0. Let's take the derivative of this. This is a chain rule, right? Yes, exactly, because omega naught is constant. I'm only doing this with respect to omega because we want to show that the amplitude is maximal when omega equals something. Beta is a constant, omega naught's a constant. So this is 2 omega naught squared minus x to the first times the derivative of what's inside, which is just times -1. And then times this, which is just plus 4 beta squared. Yeah? Cool? Okay, so move that over from the 0. I get 2 omega naught squared minus x is equal to 4 beta squared. And we're solving for x, right? So omega naught squared minus x is equal to 2 beta squared. X is equal to omega naught squared minus 2 beta squared. Did I do that right? Okay. And that was omega squared is equal to... Okay, well, let's just see, right? So this is... Okay, so when... This is when the derivative is equal to 0, so this is a critical point. If I wanted to prove this is a minimum, then I just have to find out what the second derivative is. So here, this was the first derivative. Do they just try to flirt? I don't know, maybe. So d squared omega... d squared x d omega is going to equal d dx of this, right? Which is going to go away. And cool. This is also going to go away. I don't care about this. It's just going to become a 1. Yeah, I'm just going to get... this is going to go away. And then I have 2 times -1 times -1. So that's going to be 2. Cool. All right. If the second derivative is positive, that means our curve is concave up, which means our critical point is a minimum. Right? Derivative 1 over y. We don't have to do 1 over y. Okay, cool. Okay, so now we've proven it, right? So, A is maximum at omega squared is equal to omega naught squared minus 2 beta. You might be able to solve all these factorial problems, but you'll never be able to solve my heart. Oh, it's cute. Okay, so omega is equal to the square root of omega naught squared minus 2b. That's your solution. Nice. Man. Shit, am I doing so else?
Well done.
Nice. Okay. That makes sense, clickbait? I think it was just squared. Sorry, 2 beta squared. Sorry. My bad. Yeah. I'm getting excited. / I'm getting tired. Nice. Okay, cool. Hey, stop. He's already mine. I belong to nobody. Okay, nice. Good question there, clickbait. Next one is from River. Okay. You sent me one. Let me go find your question. Ooh, okay. This is actually interesting. Yeah, those harmonica oscillators get pretty involved. Yeah. Harmonica oscillators are everywhere. Everything is harmonically oscillating. Okay, what? Ooh, this is a fun little puzzle. Who gave me this puzzle question? This is you, River? And you said, can you change the square root of 2 to 1 plus I where I is imaginary? Okay. So you want to know what 1 plus I up n is for n approaches like infinity, I guess, right? Yeah. Okay, and we make the definition that a up b is equal a to the a wait a to the a b times. Okay, so that's a to the a to the a. Is this just not a to the a to the a to the b? Mass or aesthetics? Always mass, baby. Aesthetics is if you just want to attract like other gym bros. Mass is if you want to be able to do things and like attract women. Good luck solving this problem, dude. Oh, do root 2 first? Okay, thank you. Cool, I appreciate that. Okay. So...
what is it?
Is this right?
It's
is this right?
Repeated.
It's repeated?
Exponentiation.
So is this square root
So like
of 2?
Power of A, power of A.
Is this kind of what's happening? Right?
So say A up arrow 2.
Yeah.
Say you change for the first one, change B to say 7. It'd be A to the power of A to the power of A 7 times.
Okay, so if I had A up arrow 7. Wait, why is there a double up, by the way? why are there 2 of them?
So
Can I just say
it's arrow notation.
Oh, okay. So this you're saying is the same thing as A to the power of A to the power of A to the power of A 7 times? 1, 2,
No, it'd
3.
be like A to the power of A to the power of A. Not
Okay. A to the power of A to the power of A. Is that right?
Yeah, for the thing you have on the left, you can't do that because that'd be the same as.
That would just be A times
Yeah,
A to
like that.
A to the A to the A to the A to the B, right? Which would be A to the A times
like
B.
that, B times.
Yeah. Oh, so this is like nightmare mode exponentials.
Pretty much.
Okay.
Yeah, like that.
Let me just see what this would be. Let's do a basic one. What if I do A up arrow 3?
Well, it only converges for some numbers.
It only converges for some numbers, he says. Oh, okay. But let's see what this would be. So this would be A to the A to the A to the A?
Yeah.
Yeah, that's
be-
correct?
Yeah.
Okay.
If
So
it were
if...
three.
Okay. Oh, I see why this is fucked. Because I don't know what square root of 2 to the square root of 2 power is.
Well, you can,
right?
You write it as, I guess, a to the power of 1 over 2. Or for square root of 2. It'd be 2 1 over 2.
Becky's asking, well, what's the question here? Let me show people what the question is. There it is. That's it. I've never known how PEMDAS works for nested exponentials. I agree. No, I can solve it live for sure. Alligator person. Yeah, there's a website down there. Just submit a question and I'll get to it. And then yeah, same thing, Nadson, if you want to submit a question. Okay. I'm gonna admit, River, this is like outside my wheelhouse. Like I have no clue what's going on. You want to teach it to me? Do you know the solution?
Yeah, it's 2.
The answer is 2. Oh my gosh. Ange says it will include a Lambert function. A Lambert with function. What's a Lambert function? Y'all scaring me, dude. Are we doing tetration? Oh, it is. Someone did say this. They said, okay, oh, you're right. Okay, here we go. Infinite tetration, dude. Iterative tetration. Yo, what's going on here? All right, something's trying to load on GeoGebra.
It takes a little bit to load.
Right, Femvox says because 3 to the 27th and 27th to the 3 aren't the same. Oh, this is pretty, dude. What? And I can drag this? Yo, what? Excuse me? What's going on here? This is so fun.
It's a range. If it goes out, then it diverges. And also in the range.
Bro. I feel... Okay. This needs to be installed at Burning Man as like an art exhibit. I would have so much fun with this. Yo, what is... Okay, wait. What happens when we get to here? What's going on? Can you explain what's going on here?
Well, for some numbers, it oscillates, and for some numbers, it diverges.
Okay.
For imaginary numbers, at least. And in some cases...
Like, what's going on here?
Yeah, it kind of oscillates.
That's so cool.
And the reason there's a gap in the middle is because it's only so many iterations.
Oh, like it would keep going to infinity, but the computer just like runs out. Oh. Holy shit, this is really cool.
You can put it for real numbers too.
That's super cool. It's almost like, reminds me of like fractals or something ish. No?
Yeah, there are fractals you can get from it.
Oh, very cool. 1 second. Okay, is there an easy way for me to solve this? This question, so we can demonstrate something that I love new math. I love really cool, awesome math. It's fun to see this stuff. But also I want to make sure I help kids who have tests tomorrow. So what's the cool trick for this one?
I don't really know the proof myself.
Oh, you don't know it?
Or I don't understand the proof.
He says, okay, 1 sec. Someone on my YouTube, Anch has like a solution. One. Let me go see it real quick. Where's my chat? Chat, where'd you go? Where's chat? Oh, there it is. Okay, cool. 1 sec. Here we go. Okay. Anch says it will include a Lambert with function in the answer and solve for t, and you get t equals 2. What was the visualization we just had? Okay, cool. Here, let me send that for people so they can see it. It's an iterative tetration, apparently, of the complex number z. Let the tetration be t, so you get 2 to the t over 2 is equal to t. Okay, let's try to explain that. I love you, Odin, dude. You're hilarious. Because it's square root of 2 to the square root of 2 and on for every time, for forever, you do x equals square root of 2 to the x. Oh, I think so it's almost like recursive.
Kind of.
Okay. Is equal to t. Oh.
Yeah, pretty sure you can do that.
Oh. Ouch, this hurts so much. No, because I see this. Okay, so 2 to the t over 2. I see it. I see what you're saying. Oh my god, yes. Because 2 to the 1 over 2, right, is equal to the square root of 2. I understand that. But then this is doing it t amount of times, but then there's also a t here.
Well,
Okay.
I guess you could think of it as 2 to the power of 1 over 2 to the power of square root of 2.
Yeah. It's not 2 to the 1/2 is equal to 1. Not t to the 1/2 is equal to 1. Hence t is equal to 2. Oh, I see. Oh, that's cool. So you're saying that, right, if this is 2, then this is also 2. That's the solution. Oh, okay, cool. And then you try to get some form of x e to the x with the equation, and then you take the Lambert. What level of math is this? I think it's cool, but like, where would I see this? I'm very curious. What's a Lambert function?
I don't know. I just noticed.
It's cool.
You
No, I
don't really
think it's
cover it.
Okay, I want to see where this is like covered. Wait, where is this like covered? Take the t through. No need of Lambert. I made a mistake. Oh, you don't need the. Okay. All right. T is also 4. That is true. 2 has these weird properties, right? Because 2 times 2 is equal to 4, but also 2 to the 2 is equal to 4. Yeah. Pretty sure it has infinite solutions. But apparently the answer is 2. Or the answer is also 4. Are there other answers it could be? Take the t through. Okay, I'll do it. So you want me to do this? They want me to do this. Okay, so that's like 2 to the t over 2 to the 1 over t is equal to t to the 1 over t. And I think when I take exponents of exponents, right, we multiply them together. So that's 2 to the 1 over 2 is equal to t to the 1 over t. Is that correct so far? Sorry, let's get rid of this. We don't need this. Chat's helping me through with this. I appreciate it. Oh, so, and is this the definition of what we already had? Now compare. Okay, now compare. What am I comparing, though? I see the square root of 2 is equal to t to the 1 over t. And we also said... Oh, what's the comparison, Ansh? Sorry, I'm missing the comparison. What would t be? 2? Oh, that is right. Okay, cool. Yeah, so t is equal to 2. And I guess it's because this original thing, 2 to the t over 2, is equal to t. This is kind of what described the situation that he already had. Fembox has an annoying question. No, it's fun. I like it. It's fun. I really appreciate the visualization. This is like tripping balls, dude. This is blowing my mind. What is this stuff? This stuff is so cool. Nice. Math is pretty. Okay, cool. I appreciate the question, River. Thanks for expanding my mind on stuff. This is really cool.
It's sad that there isn't much stuff on it, though.
No, but that's cool. What's your background, River? By the way, are you a grad student? Are you just a math lover? Like, what do you like to do?
I just like doing math.
You just like doing math. Cool. What's your background in math? Maybe that would help. Yeah.
Mostly self-taught for everything.
Oh, that's sick.
So.
Good job.
Dude, I feel like I'm pulling teeth sometimes to get students to learn math, and you just do it on your own, which is really admirable. I feel like
yeah, the issue I have is I get stuck at stuff like I run into a wall and I don't know what to do.
Uh-huh. But that's kind of fun.
Yeah.
That is kind of fun. Nice. Okay, wow, someone's got one with like a remainder function. Here, let me see. I'm going to choose, I know we have like an order of things, but I'm going to make sure, I want to try to help people who haven't asked questions yet today. So, Julian, I know you had a question. Let me do this one first for Julian. Just also to maybe like tone down the math a little bit, because I know some of my viewers are probably like, what the fuck's going on?
Oh no!
I like it. I like the high level math stuff, but yeah, it's also good to have like a little bit of balance. W stream, appreciate it. Dude. Yeah, Ren, you have a cool one as well. Let me just do this because I feel like this is easier to less rare math. Yeah, this is common math. Okay. Given f of x is equal to that and g of x is equal to that, evaluate the quotient of f of x divided by g of x. Cool. Isn't there a rule here? I think I just plug in 6. Right? Don't I get the answer if I just plug in 6? I think that's like that's a cool thing. Given f of x is equal to that. Okay. Let me just write it. Negative x plus 6. It's negative 2 comma 2. Maybe. And then we're dividing this by negative x plus 6. So wait. Correct me if I'm really wrong here. Don't these two things just cancel? And then this is the answer? Or is there like a cooler way to do this? I could think about maybe like foiling this and then doing long division. Is that the other way I want to do it? Good. No, you know, I'm glad. Yeah. And then solve for x. Okay, so is it equal to 0? Well, here's the question. I just said f of x was equal to this. Okay. Let me try to show... Let me show, like, the brute force way to do this. Because I like brute force ways. They're kind of fun. Let me foil it and just see what happens. Dog says don't do it. Come on, dude. You don't want me to do it? I think it'd be fun. Negative x plus 6. Oh, stats can be hard sometimes, dude. Yeah, negative x plus 6. Yeah, right? I'm just curious. Exactly. River, you're 100% right. That's what I want to do. People are yelling at me. And I'm like, no. Let me show you what I want to do here. I'm going to just foil this thing, and then I'm going to long division it. So this is negative x to the third, plus 2x squared, minus 4x. You said an integral, Lucas? What's your username? Is it Juliant Lamb? I see something from Renren. I see something from Odin. Yeah, we got a bunch of people in the queue, but I'll do them. Sorry, am I really fucking up here? Sorry. Yeah, I don't know. Sorry, I was distracted by chat. I'm sorry. Thank you. Thank you, Vihan. Dr. Gold, what's this math? Is it 67? If it's... Oh, oh, it is 1, 2, 3, 4, 5, 6. Cool. Okay, Julian. Yeah, I see you. Sorry, let me just do this. Negative x to the third plus x squared minus 4x plus 6x squared minus 6x plus 24. Yes. Yeah, I'm still going. It would have ended, but I'm feeling generous today. Okay, negative x cubed. Also, we've gotten some donations today. W Europe. I think I've gotten euros. Did I get Canadian dollars today? So yeah, that's pretty cool. Okay, minus 10x plus 24. Y'all keep the lights on. That's what I'm doing. Am I not allowed to do that? I feel like I can. It's a free country, right? Still, I think. Okay. And then let's divide this by negative x plus 6, right? So I'm literally going to do long division. This will teach people something. Someone gave me 5 Canadian dollars. Nice. Dubs. So wait, Canada and Europe. I'm going to guess Pietro is from Italy. I used to have a really good friend growing up named Pietro. Okay. How do they give me money? Oh, there's like super chats that I qualify for. You can write me a super chat. I think I get cash from it. Sorry, I won't show any like feet pics or anything. Sorry.
No.
Okay, so how many times does negative x go into negative x cubed? It goes in x squared times, right? So then we take this, we multiply through. So that's negative x cubed plus 6x. And then this is always the part that kind of messes with students. You have to subtract the whole thing from this. Okay? This will always cancel. Because that's how you intended it. And then you have 7x minus 6x. That should just be equal to x. Alright, sorry, this is 7x squared. This is x squared. My bad. Thank you, Fembox. Yes, x squared. Okay, now I say, how many times does negative x go into x squared? Well, it goes in negative x times. So that, again, gives me x squared plus 6x. This is a minus 10x. Subtract the 2. These go away. You get minus 10x minus 6x. So that's negative 16x. Okay. And then I say, how many times does negative x plus 6 go to negative 16x? That's a positive 16 times. Okay. So now we have negative 16x plus, is that 144? 6 times 16? 60? No, wait. Fuck. Am I fucking up? No. 96. I don't know what I'm doing. Sorry. Thank you, Vihan. Is it positive 6? No. It was minus 10, right? That came down here. Did I screw up already? Oh, wait. It's minus x, right? This was minus. Thank you. So it's plus. Thank you. I screwed up. Sorry, my bad. I'm hitting this is almost the 3-hour mark of streaming, so I'm getting tired. Okay, let's lock in here. Let's lock in, chat. Negative x squared times minus 6x. Cool. So it's negative 10x plus 6x, which is going to be minus 4x. None of this aesthetic nonsense anymore. I guess mass is law from now on, yeah. Okay. And then I see how many times does negative x go into negative 4, and that's 4 times. Oh, no. A cubic that goes through 4 points? Dude, yeah, that's brutal, dude. What? Okay, minus 4x plus 24. Oh. Shit. There's no remainder. Wait, this is dumb. Wait, do I literally I get the same thing? Okay, fine.
That's dumb. Oh, no.
There is no remainder. Oh. Sorry. Okay, I'm really tired here. I thought there was a remainder we were looking for. There is no remainder. Yes, sorry, mathematics. Dude, no. I totally blanked out, and I read quotient as like find the remainder. Sorry, guys. Yeah, no, I'm losing my mind. Yes. Okay, duh. I just did it the really hard way. Yes, but look, we get the same answer. It's always good to verify. Also, like, it's good to teach you guys how long division works. Yeah, okay, cool. That goes away. Same answer. Great. Awesome. Love it. Thank you, dude. Appreciate it. Yeah, it's one of the many things we do. I mean, the stream is like a good funnel to get people into our community so that, you know, they improve their lives and stuff. For those that are watching, yeah, no, I have a whole Discord where let me give just a quick rundown of like what we do as a nonprofit. So I got about like 1,700 people in a Discord, and what happens is people on our Discord earn points if they do different things. So for instance, I have students, we have like a physical education channel. I call it like the touch grass challenge. So if students show me that they have steps on their pedometers, you get points for that. If you show me, for instance, you have good grades on your tests. So someone showed me, hey, look, I did well on my kinematics test. I'm like, great. You get points as well. If you practice a musical instrument, someone here, Bobby the Goat, is showing me how he plays piano. Great. Love this. That's sick. Love that. You also get points. And then, yeah, if you ask questions here on the live stream, you also get points. The more points you earn, the more prizes you earn. and we're a nonprofit, so we get like donations and stuff. And I've bought like lots of prizes. Here's just like all the screenshots of like all the prizes. I've probably spent like 10 grand in prizes over the last like 3 years. I bought a gaming desk for someone once. Like that's what they wanted. So yeah, lots of gift cards. And then we have like bigger events sometimes where someone won a laptop. I sent them a laptop. So that was back in 2022. That was cool. So we've been doing this for a while. The streaming has only just like really picked up recently. Yeah, if someone hops on gear, would they get points for that? No. The stream is dope. That's dope.
That's dope.
Okay, cool. All right. Let me go back to questions. All right. Where were they? There they are. No, it was here. This one, Julian. This is yours? Okay. Okay. Someone is really trying to hurt me tonight with questions. Yeah, you can definitely win a laptop. It's happened, dude. Yeah. If you do well during like one of our summer tournaments, it's during the summer. I get like a lot more funding, and then like I do like big events. But you could easily. I have students that the first gift we give out is like a $10 like gaming gift card. Kids get that in like a week and a half. If you like really try in the server, it's easy. Okay, is this your question, Ren? Is this the one you gave me? You trying to hurt me here? How do I get funding? I mean, the stream helps. I got a couple bucks here today. A lot of it's like I apply to grants. I get private donors that just donate. They think what we do is cool. The eventual goal is to have Google pay me more with like AdSense, right? With these streams. So that's why I do these. I do these streams as like exposure as well to hopefully funnel in some more cash. This hurts to look at. I agree, Omar. Omar, how'd your test go, by the way? Didn't you have a test that we helped you study for yesterday? Okay. I have no fucking clue what a gamma function is. Anyone want to explain to me what a gamma function is? This does happen at some points during the stream where for whatever reason the algorithm just starts sending me towards people who have really awesome high level math questions. And I'm always down to work through them. It's fun. My primary knowledge is helping middle school, high school, early college, but I will try to do this. Oh, nice. You got 92 in the quiz. Dope. It's a continuous factorial. Okay, let's look it up. We're going to learn some stuff. Okay. That was number 4. Gamma is a complex extension of a factorial. Okay, let's see. Gamma function is equal to this. Cool, I like this already. This is like useful, right? Okay. Continuation of x factorial while x is not natural. Wow. Dude, what's with these awesome like symbols? Like graphs and stuff. You guys got like the cool stuff, dude. What? X isn't natty. Okay. Okay. All right. Can you do chain rule with derivatives? I can. You want to give me a screenshot of a chain rule with derivatives? You want me to do like a question? People submitting questions are giving me very hard ones that I can't really solve right now. Factorial x, but if x is on gear. Odin, that's what it is, dude. Okay. Dude, this is like the dark mode. Dude, Wikipedia for math is the same thing as WebMD for like I have a headache. You're gonna start going down dark places and you're gonna think you have cancer. Zifo Zonky, can you solve my... I do see your question. Let's see. Let me see how ChatGPT does this, and maybe you guys can help me explain this, because I don't really see how to do this real quick. One sec. It does use the Euler equation, and it uses a Laplace transform. Oh, okay, cool. One sec, I gotta reload this. I have no idea what I'm looking at, but this looks nice. I agree. It does. All right, let me start in. You guys have broke the amount of time I've been on this. Okay. What class is this equivalent to? I honestly don't know. This is kind of like some specialty math stuff. Okay, so they go first off into writing cosine of 2x in terms of the Euler equation, which is cool. You can always write, for instance, cosine of x can be written as a summation, a sum of exponentials, which is the same thing as e. So cosine of x is the same thing as e to the ix plus e to the minus ix all over 2. This is very useful. You will use this outside in like other math classes. This is definitely university, right? So if you had cosine of 2x, right, all that happens is this x gets replaced by 2's here. Okay? So now I have cosine of 2x is equal to this. And then we have to use this, which I guess is a given, which is that this kind of looks like what I got here. Except, it's got a Laplace, right? All right. This a to the s is the e to the a. Yeah. So I think in Laplace land, right? 0 to infinity of like e to the a is the same thing as like a to the s when you pull it out. You think there's a placement test I can do? Yeah. Have you ever tried doing Mensa? You should do Mensa. Mensa's a big like IQ test thing. Or any of the math competitions. So like the what's it called? Mensa. Yeah, one sec. Let me show them real quick. A lot of you really smart math people are asking about things. So Mensa IQ test. This is a big one. Yeah, you can get like certified or something if you're really smart. This is a good one. And then I want to say, what is it? The Waterloo math competitions. Yes, whatever this is. The center, CMNC, these. Where is it? Where's the math one? Yeah, okay, so there's the Euclid, right? Euclid is one. I think there's also like the Cayley one. Or the Fermat contest. Yeah, there are a bunch of math contests out there for you guys that are really interested in math. Okay. So then here's what they say. Yeah, you're gonna try it next time? Cool. I applaud that, dude. Yeah. If you're good at something, always try to test your limits. And don't worry about failing. Or like not doing as hot as you wanted to. It's better than like not trying. I think that's one thing that I really resonate with how I got to where I am, is I was totally cool with failing a lot. And that's the only way you can get better at things. So if you think, don't be scared to try with stuff. Okay, let me just try to break down what the solution is, and then Zimfunk, I will help you out because you have like an applied math question. I feel like I'm too much in theoretical land right now. Okay. So what was the original thing? It was this. So in this case, S was equal to 2i plus 2, right? That's how you get 1 plus 2i from z minus 1. And in this case, negative t was 3 plus or minus I over 2. Wait, why is it minus plus? Wait, why do I care about like which one it is? What? Okay. So they put the minus here. Oh, and then you have another one, which is plus. Oh. Because that's what cosine is. Oh, very cool. Cosine of 2x is this. So when you combine this term with the e term here, you get e to the 3 minus plus I over 2. Very cool. What's up, 9 Gaming? Showing off some square roots. Okay. And then each one of these is its own gamma function. Okay. The thing with failing is your GPA will get lower and you might not get into a good college. Okay, sorry. When I mean failing, like don't fail your classes. I mean failing like challenges and stuff. River has a good one. He says you don't have to climb the mountain in a day. Just take one step. As long as you keep moving, you'll make it eventually. Yeah, perseverance is very important. So yeah, for a contest, there's no punishment really if you fail. So won't affect. Yeah, just try it. Okay, cool. This was a cool question. Let me work on to something a little bit more applied, and then I do have to go run. I have to go tutor a student in algebra. So here, Zfunk. You let me know which one you want me to work on. What's the best way to study math? Do problems. Practice problems are great. Let me see all the other ones. We did have a lot of questions today. Ren. This one's cool. X to the 100 plus 1 is divided by this. What remainder does this yield? Wait, was this... Can you do this with long division? Or does this just become an absolute mess? Because you have like 99 terms behind this. I'm going to wait for Zfunk to tell me which one he wants me to do. And then Odin, I appreciate this one. This one was good. Contour maps. Number 2, number 4. All right. Okay, determine the moment of inertia for the shaded region around the XY axis. Okay. So that's about here, right? So about this axis is like coming out of the page. I believe the equation for moment of inertia is something like, is it RDM? Integral of RDM, dA? Yeah, no, I think this is moment of inertia. Wait, one second. Let me... No. I'm going to remember it without even doing it. I think it's the integral of R dm over the integral of dm. Correct me if I'm wrong. I think that's what it is. Yeah, because it's like summing up all the MR squareds, but what is it? Oh, that's the center of mass. No, this is what it is. It's R squared dm. Yeah, okay. No, I got it. Sorry. Yeah, sorry. This is the center of mass. That's what I'm thinking about. Sorry, center of mass. Yeah. Okay. So, I is equal to the integral of R squared dm. The Loon of Hippocrates. You know what we also did? We did the window of... Who is it? Somebody's window. Viviana's window. We did that a couple streams ago. That was hard. Okay. It's R squared dm. Okay. Where... Okay. dm is equal to... rho dA, right? Okay. So I believe... Okay, well, about the x squared is the integral... But I thought it was about the... Oh, sorry. I thought it was about the x... Sorry, I thought it was about the z-axis. I fucked up. Sorry. I saw x-y axis. I thought it was like the xy plane. I thought we were doing this moment of inertia. That would have been easy. Okay, about the x-axis is the integral of x squared dA over the integral of dA. The same thing for the y-axis. Okay. But is there not a mass in there? I feel like there has to be a mass for moment of inertia, no? Oh, this is the kind of TikTok I like, yeah. I think it's this, no? Where's this 1/2 coming from? Yeah, because then you can get into like tensors. One sec. How are all our platforms connected? It's called Social Stream Ninja is what I use. Yeah, so I have you on TikTok. I got you on Twitch. I got you on YouTube. And then also on the right here is Discord. So we got all of them. I think it's a cool way to like bring, because I have different communities on all of them. Like my Twitch community is probably my tightest and most intimate and like the most constant. YouTube is probably the best exposure. I get the most people I see on YouTube, like new people for sure. And then TikTok are like people that watch my tutorial videos. So it's about like bringing the world together. Okay, but I need to figure this out. Because I know if we were just doing around the z-axis, right? Isn't that just the integral of like little mr? Like I just do mr squareds. I just here. I know this, right? If I'm finding the moment of inertia about this, right, in this axis, and we're looking at stuff here, all I'm doing is adding up mr squareds, right? Okay. All right. Yeah, if I know the integral, I can do it. I guess it doesn't depend on the mass, which to me is interesting. I feel like it should. Or is this what it is? Oh, okay, wait. So, Ix... I think I'm getting this. Ix is equal to m, and then it's adding up all the little... like mr squareds, but in this case you're doing the y strips, y squared dA. Yeah, okay. I have not done much group theory, but I have other people in my stream that have. Okay, y squared, let's do dy dx. Here, let me pull this into its own little page. Get rid of this. So people can see what's happening? Okay. So, in terms of y, right, we go from y equals x to y equals... Oh, I see. We got to solve for this. Okay, so if y squared is equal to 2x, then y is equal to the square root of 2x. Okay, so let's set our bounds here. So... dy, y is going to go from this bottom line to this top line. So that's x to square root of 2x. And we still got y squared, dy. And then x is going to go from 0 to 2, right? That's our bounds from x. Y dy dx, I'm confused. Okay, so area. Area is dA, right? This is area. And area is equal to usually x times y. Thank you, River. I appreciate that, dude. Thank you, dude. Come by anytime. So, yeah, dA, right, is this area. And so, you can think about, like, infinitesimally small pieces of area that have a width dx and a height dy. And then the area of this infinitesimally small square is just dx times dy, right? Does that make sense a little bit, Zifo? I'm just taking the definition of what you said it is. When I see this, I know what dA is. dA is just dx dy. Okay. Cool. right, so now we got to evaluate this. So this is dy dx. Okay, cool. So you do the integral of dy. So that's going to be y to the third over 3. Evaluated from x to the square root of 2x. So that's going to be equal to square root of 2... square root of 2x altogether. So square root of 2x all to the third over 3 minus x to the third over 3. So now we're left with integral. Here, let me like just put this into here so you can see what's happening. So that's 0 to 2. And then that's going to be square root of 2x all to the 3 over... Let's pull the 1/3 out. Just pull the 1/3 out because I know I have a 1/3. So it's this minus integral from 0 to 2. And then we're going to do this integral. X to the third. And then all that's left is now the dx. This is on everything. Is that good so far? So what Zifo, I took this to evaluate what like this first part of the integral of the double integral was. And now I'm going to do the outer integral, which is 0 to 2 dx of each one of these things. And I also pulled a 1/3 out just to make life a little bit simpler. Because this integral is easy. How to do optimization? Optimization is great. Get stuff in terms of one variable. Make the derivative equal to 0. Evaluate. So this is x to the 4th over 4. Evaluate it from 0 to 2. This is a little trickier. Because this is the same thing as... So we can pull out the square root of 2 cubed. So you have square root of 8 on the outside. Let's just do that. And then this is the square root... The square root of x to the third. So that's x to the 1/2 all to the third. So the same thing as x to the 3/2. So raise the power and then divide by it. So you're going to get square root of 8 times 2 over 5 x to the 5/2 from 0 to 2. And then all this is still times a third, right? All right, so let's see what happens. So nice thing is the zeros all go away. All right, I don't care about these. Plug 0 in, we're awesome. This is also a minus here. So we got 1/3 square root of 8, 2 over 5, 2 to the 5/2. Oh, that's so messy, dude. 2 to the 5/2. Oh, 2 to the 5th is 32, right? Square root of 32. Minus 2 to the 4th over 4. Okay, what do we got here? 2 square root of 8 over 15 times 2 to the 5/2. Minus 2 to the 4th over 4. And there's also a 1/3. Thank you. Thank you, Fem. Also 1/3 there. Yeah, I forgot the 1/3 has to come in for both places. Oh, man, this is ugly. Oh, wait. Square root of 8 is 2 to the 3/2, right? Or we should have just left it. Sorry, my bad. Right? Because 2 to the 3/2 times 2 to the 5/2 is 2 to the 8/2. 2 to the 8/2 is 2 to the 4th. So 2 times 2 to the 4th over 15 minus 1/3. 2 to the 4th is 16. 16 over 4 is 4. This is 32 over 15 minus 4 over 3. So that's 20 over 15. 12 over 15. Divide by 3. 4 over 5. And then... Well, I think there's an M on it. Yeah. Okay. So I think this is the moment of inertia. I don't know. Is it m? Or is it m to the 4th? Or is it m squared? Is this physics? This is applied math. Kind of physics. That M is the area of the shaded region. Yeah, I agree that's the area of the shaded region, but like what's the equation? How do I know what the how do I know what the exponent is on this? What's up, Liam? It's usually m to the 4th? I mean, if you say so. But why is that? Why is it usually m to the 4th? Oh, integral of r squared dA? Oh, dude, m is not mass. Oh. Oh my god. Okay, sorry. That's units. Okay. Oh my god, I'm so dumb. Sorry. Okay. Yeah, okay. Yeah. All right. It's meters to the 4th. And the reason for that is dA is going to be meters squared, and then y is going to be meters squared. That's why I get meter to the 4th. Okay. Sorry, m is not mass. I thought m was mass. I thought you need a mass term in here. Okay. Okay, so if you want to figure out the moment of inertia in the y direction... Let me see, one sec. Do I have a student? When do I have another student? Sorry, just making sure. Okay. Alright, I gotta go in like 10, 15 minutes. We have been streaming for 3 hours and some change. Pretty good today. Okay. Let me do I in the y direction, which I assume is the same, but now it's x squared dA. Right? Draw Bambi now. I don't think I could draw Bambi. Is it the same thing? Can I do dy dx? Can I do the same thing? Or do my slices have to be Yeah, the way I'm handling the problems. Thank you, dude. Do the I-beam? Ooh. I don't know if I have time to do the I-beam. You said to do number 2. You didn't tell me the I-beam first. Wow. Okay. I feel like you just have to add it up for all the different shapes, no? Like the same way we did this. So when we did, I'm gonna skip the I one, I to the y. Where is it? When we did ix, right? It was y squared dA. I see, because it's around. I see, because you're treating like a bunch of mr squareds around this axis. Use the parallel axis theorem. Would you be deciding to then do it from here? Is that what you're saying for IX? So for instance, you do IX from here and then just multiply it by... Just add, sorry, you add MR squared. But where's the mass in any of these terms, dude? Or is it just unitless? This is what I get confused with. This applied math stuff. There's no fucking mass on any of this. Ooh, good question. Do we? Yeah, I'm confused. Yeah, I mean, it's like two different questions, I feel like. Oh, no, no, no. You have to just do it for all the different ones. Yo, what's up, Bobby Dragon? Okay, Mike says moment of inertia can be expressed as the moment of inertia can be expressed as the second moment of area. That's why it's units to the fourth. Okay. Ah, but there's no mass term? I'm used to moments of inertia having mass in it. I'm a physicist. I'm not an applied math guy. Mike says, oh shit. For the I-beam, you need to determine the centroid if it's not doubly symmetric. Oh, it's not. Yeah, I noticed this, right? Sorry. This is 90 millimeters wide, and this is 50 millimeters wide. So... Oh, I see. Fembox says, area moments of inertia treat the density as a constant of 1. Oh, so dm just equals dA. Wow, that's a fun little approximation. Mass is 1. Or density is 1, sorry. Okay. I am running out of time. Sorry. I do have to go teach another student, and I've been on for 3 hours and 11 minutes right now, so... yeah. Do what the guy on the chat says with the centroid stuff. I know we had a lot of questions we wanted to get to today, but we did go through a lot. So I always appreciate having more questions. Yeah. No, I see that. Okay, cool. Yeah, Ren. Yours was here, Ren, this was a fun one. He says, "Oh, sad." Genius. Let me see. Sorry, real quick, Ren. Let me spend 5 minutes on this. There were some great questions tonight. Yeah, I just want to see real quickly this. X to the 100 plus 1 is divided by x squared plus 5x plus 4. What's the remainder? This is the same thing as x to the 100 plus 1 over x plus 5 times, sorry, x plus 1. Yeah, it's the factors. Bro, this is such a fun one. Actually, sorry. I'm glad we actually did this one real quickly before we leave. Okay. So this is really cool, right? Because this is f of x, right? So f of x, you could think of is equal to... Yeah, what is this called? This is called the remainder theorem, right? Oh, I need to remember how you write this. What's the way to write this again, though? Sorry, what is it? Dividing a quadratic, so remainder is linear. No, but there's another reason like why this happens, though. Sorry, one sec. I know what it is. Let me just get an image of it. No, I think it's this. One sec. Remainder theorem. I've done it before. It's super cool. Yeah, this is it. No, it's okay. I think I have time for this real quick. When are you live? Good question. Yeah, so anyone watching wants to know next time we're live. The same website you went to go submit questions. There's also a streaming schedule here. If you click on the streaming schedule, this will tell you all the times that my live stream is on. So yeah, I'm way past my time right now, but it's okay. I had a little bit of extra time to work with you guys. Yeah, here it is. Okay. Oh, wait a minute. Okay, if a polynomial is degraded by a linear polynomial, where does e2i pi stream? Good. Yeah, here, let me give him a shout out here, because I am doing a joint podcast episode with him on Thursday. But here, I'm gonna post it for you. Here's his. He streams on Twitch.
This is the kind.
He does really cool streams. Like he talks about like math and like really high level math stuff. Yeah, and he has like a whole whiteboard. I love Zach. Zach's great. We all love Zach. But yes, this is his Twitch, and it should have it on the calendar. Where is it? Yeah, on the calendar here. Like mine has my Twitch address. His has his Twitch address. I don't think he's put it on these. I'll edit these for him so that it has his Twitch address on it. But this one has his Twitch address. Yeah. Zimfunk. Yeah, Zfo. We'll read my chat. The guy said you had to find the centroid and then you have to do the parallel axis theorem. Yeah. This is what I was thinking about. Okay. F of x is equal to, yeah, some factor x minus a times q of x, and then this is plus the remainder, right? So if you want to figure out what the remainder is, you plug in like a is equal to x, because then this goes away, and then so the function at a is then equal to the remainder at a. Or the remainder at a is equal to the function at a. So wait, how does that extend to this then? So we have this, right? So x to the 100 plus 1 can also be written as x plus 1, x plus 4, right, times some quotient of x, plus I believe a remainder of x. Yeah? And so if we plug in like x is equal to -1, well then this whole thing goes away, right? And so the remainder would just be equal to the function of this at -1. And -1 to the 100 is just 1. So I think the answer is 2. But wait, can you have 2 remainders though? Oh no. Fuck. No, you can't have 2 different remainders though. Fuck. Okay, I gotta think on this one, but this is kind of how it works. All right, sorry, I gotta end the stream. I gotta go teach. But yes, cool. All right, thank you everyone for coming to Actual Education Office Hours. Had a really fun time. Lots of fun questions today. Appreciate everyone. Our next stream is tomorrow. That's gonna be at 4 o'clock Pacific, 5 p.m. Mountain, 6 p.m. Central, 7 p.m. Eastern. If you're just watching us now, please go check out the website there, the actualdiscord.com/submit. That has all of our information. So I'm trying to think. I'm still fighting like a cold. So yeah, you can see our streaming schedule. That's when we stream. You can visit our YouTube, like, subscribe, all sorts of great things. Follow, turn on notifications if you want to find out next time that we can help you out. Twitch has a nicer like horizontal view if you want to watch on Twitch. You can join our Discord if you want to get rewards for doing well in like school and also asking questions on our stream. Also, if you want to donate, we had so many nice donations today. Thank you to all our donors. I'm gonna make something special for you guys. I'm gonna do like a little like thank you. I really appreciate that. Yes, and also awesome to Zach. he is our other awesome math streamer. He's going to be doing math chat on a topic tomorrow morning at 11 a.m. I say morning because it's morning for me. The stream is ending, Sofal, unfortunately, but I'm talking about we have other streams coming up, and especially there's a really fun one. Where is it? Yes, here's all kind of like Zach's little news he's doing. So tomorrow, Zach's talking about division of fractions and mathematical mindsets. So come on by for that. That's gonna be a lot of fun. And then on Thursday, Zach and I are teaming up for a podcast episode where we're going to talk about how math and physics get used together and in perfect harmony. You know, it's quite meta, Zach, right? Because Zach has a PhD in math, I have a PhD in physics, and we're going to talk about why our two sides are very symbiotic and work with each other really well. So yeah, sweet. Please come on by. It's gonna be great. All right, nice. Okay, so if you're watching us on Twitch, we're gonna go raid another stream. So raiding is a cool way for us to kind of support other upcoming math and science streamers, or even people that are bigger than us, or argue about why they're not. We're gonna keep it civil, right? We're gonna keep it civil, Zach. Yeah. Okay, let me see. Who are we following? Who's on right now? Moohoodle, Science, Walking Stick, High Potential, Uwoos. Okay, let's... Also, I met this girl Thug Shells at a... This is funny. Isn't physics just applied math squared? Yeah. Yes, excited. Check it out. I have a video on TikTok. Go to my profile. I have videos on how to do that stuff. Sweet. Okay, let's go say hi to Moohoodles. They're great. Moohoodles does... short stream feeling sick. She starts in 40. I'm also feeling sick today. Wow, okay. Something going around. Anyways. Okay, great. Okay, awesome. All right. Have a great start to your week. Enjoy the Monday. We will see you guys tomorrow. Peace.